So this is Morphy Towers V1, free webinar that we like to do sometimes just to show our appreciation and show some cool, more experimental fun stuff. And this webinar will be looking at a few things. We'll first be looking at using sub-Ds in Rhino 7, and then with those sub-Ds, we'll be using Pufferfish to basically do different morphing and blendings to make towers with them, and then we'll do some KeyShot rendering of them. So that will be kind of like the overview of the day. Requirements are Rhino 7, not 6. If you have 6, you won't have the sub-D. It has some sub-D, but you won't have the sub-D tools in Grasshopper, which is really important for this webinar. Plugins, obviously Pufferfish, Weaverbird, and Mesh Plus. We might not use Mesh Plus, I'm not sure yet. I just threw it in there because I use it sometimes. Depends what we get into. And yes, there will be a recording, which will basically, after this is done, there's a lot of people, so, and we can't send so many emails per day without getting blocked. That's just unfortunate thing about email. But it'll take between a day to 3 days, and you'll get an email to the Zoom recording, which will be viewing, and then for you guys that are here live, will also be a downloadable version that you can keep. You can just keep it. So that's cool. So another reason why if you're feeling behind or less experienced, don't worry about it. It'll be fine. Again, there's no panic in here. We're here to just have fun today, or tonight, wherever you're based. So before we get into more of that, I just want to point out a few things that we have coming. Can we have the certificates? Check out the website, you'll find your answer. So the first thing I want to point out is our master's degree, which the registration has ended. But if you're interested, please send us a message, and we'll be opening for next year. Right here, Design Morphy Masters, a fully accredited master's degree in computational and advanced design with tutors from all the great places like Zaha and Big, and just a lot of great tutors there. The other thing I want to point out is we have 2 webinars next weekend. They're not free, but in terms of this kind of webinar, they're relatively very low priced. Usually these kind of webinars would be hundreds of dollars. We have Bionic Articulations 2, which is a ZBrush sculpting webinar with with Pryor Mystery, who's the principal of Studio Sympathia. If you don't know Studio Sympathia and Pryor, definitely check out their Instagram here. Really great modeler in ZBrush. So if you're interested in that, definitely sign up for that. It starts on next Saturday. We'll be learning a lot of really cool stuff there. And the other one, MoGraph Volumetrics, which is Cinema 4D for architecture, parametric design webinar, which I'm really excited for as well. And it's with Amazing Architecture. I don't know if you follow, but if you don't, you should here. So if you check out their site, their Instagram, you should definitely be following them. Definitely one of my favorite architecture designers in this space right now. Really beautiful, talented work. So we'll be looking at how to do this kind of stuff with his tool of choice, which is Cinema 4D. It's going to be really a lot of fun. And lastly, I want to just point out if you see here, CD Next 5, our conference, which starts in 2 weeks with parametric architecture. Um, so I'll just paste that for you. Check that out too. It's 2 days, about 8 hours a day of lectures and webinars from all kinds of designers in this computational advanced design space. It's going to be really good. And we actually just added one more, the CEO of Branch Technology. I don't know if you know them, but they do humongous scale 3D printing. So check them out. We have different webinars going on too, and also for quite low price. So definitely check that out as well. It's a lot of fun. So let's, since I know a lot of you are applicable for Rhino Grasshopper users. Yeah, they're definitely applicable. It's this whole kind of ecosystem, just with different different tools. So yeah, definitely go check those out. So now I just want to go over installation. So first thing we're going to do is we need Pufferfish. So just go to Pufferfish. Okay, so we're going to be using 3.0, which is the latest one, and we're just going to click download. And once you have it downloaded, basically what you want to do is, because a lot of, I would say most networks block the downloads automatically. So first thing you do when you download something for Grasshopper is just take the zip file and right click it and go to properties and just check this unblock, right? So that unblocks it. Otherwise, you can import, put it into Grasshopper, but Grasshopper won't be able to read it. Yes, Pufferfish is the tool I developed, yes. And then apply and OK. And then you're going to extract. So use whatever kind of zip extractor you're using, and you'll get this folder. And in this folder, you have the GHA, sub-D components, and instructions if you've never installed before. So you can just look at those instructions as well. So what you're going to do is you're going to, how can we update? Just delete V2.9 and put V3.0. So let's get this here. So in Grasshopper, you're just going to open Grasshopper and you're going to go File, Special Folders, Components folder. Right? So that's where all your GHAs are going to be. Right? And it actually brings us a folder called Libraries. You can see these are all my installed plugins. And you can see there's Pufferfish. I already have it installed. So you just take it here and just copy it into there. I'm not going to do it. I already have it, but just drag it in there or copy it in there. And that's all you need, right? And the next thing is the work in progress sub-D components, because they're user objects, because there's some sub-D things that aren't coded yet. So you just go File, Special Folders, User Objects folder, right? And you can just make a folder called Pufferfish, or just drag this whole Pufferfish work in progress, just drag the whole folder in, right? And you'll see it's in there, right? So that's again in File, Special Folders, User Objects folder, okay? So that's for Pufferfish. Now let me go back here to here. So Mesh Plus. Which I'll just paste here as well. Oops, sorry. pasted the search link. Here's the actual link. What are the system requirements? Just check Rhino system requirements on their website. I'm not sure exactly what they list. Where to download this software? I mean, that's what I'm showing now, so I'm not really sure what you're asking. And the links are in the chat. So Mesh Plus, you just download the newest one here, 2.1.03, download it. Mesh Plus is a bit heavy because it's all user objects. User objects are a lot heavier than GHAs like Pufferfish is. And you want to do the same thing, properties, unblock, apply, okay. And be careful with Mesh Plus because I think it's not in a folder. So what I do is I make a new folder, bring it in there. Otherwise it's gonna just put like all this stuff on your desktop and then extract here. And it's gonna give you all these user objects. Right, so then just go File, again, Special Folders, User Objects, and you can make a folder called Mesh Plus, like I have here, and just copy all of this and drag them in to that folder. Yeah, we didn't get to Weaverbird installing yet. So there you go. That's how you do Mesh Plus. Okay, and the last one is Weaverbird. Weaverbird. Now for Weaverbird, it's a bit different because Weaverbird's using the Yak package manager, which Pufferfish will use in the next version. It just doesn't use it now because it's still supporting down to Rhino 5, which doesn't support Yak. So once the next version of Pufferfish comes out, which will be only for Rhino 7 and up, it will be installed the same way that this one's installed. So basically, click download Weaverbird for Rhino 6 and 7. And what it's going to do is it's just going to give you a Grasshopper file. And basically that Grasshopper file is it already has Weaverbird plug components in it. And you just drag this onto the canvas. I'm not going to do it because I already have it installed. And when you drag that into it'll bring up a prompt and you'll be able to just install it directly from that prompt. Okay. So that's how you install those plugins. So the next thing that we want to do, position my okay. So the next thing that I want to give to you is the Dropbox link. So please, everyone, download that file or that folder. And in that folder, you're going to have it's going to be downloads. So this is what the folder is going to look like. What it has in it, basically. And it's going to have some files. And it's going to have Grasshopper. So the start file is just a blank file. Like I have, it's basically the blank start file. It looks like this, okay? What you see here has some models in it. And then there's a working file. So the working file is actually the file I'm working on right now. So as we're doing this webinar, I'll just save. And if you ever get behind and you want to catch up quickly, just go back to the Dropbox link and re-download the working file. And it'll be to the latest point that I've saved that. Same, same with the Grasshopper definition. Right now it's empty. It looks like this. There's nothing in there, right? And I'll just be working in this file. And if you get behind, because I save a lot, so if you get behind, you just go and re-download this file and you'll be at the point I'm at. Hopefully that works out. And then there's KeyShot. What we'll do with the KeyShot is there's just some environments and materials I use for those promo materials if you want to use them when we get to the KeyShot part. If not, KeyShot's got tons of materials and environments already built in, so you can use those as well. So please go download that, that entire folder. Okay. So once you've installed Pufferfish, Mesh Plus, and Weaverbird, I suggest that you fully close Rhino and Grasshopper and restart. This way, sometimes the tabs don't come up until that. Great. So Pufferfish here is my tab. And with the here, you know, with Pufferfish, there's 330 components that I've scripted, all very useful that make a lot of things in Grasshopper very easy. But the main premise is blending and tweening of things, basically going from one thing to another thing. We'll be looking a lot at, you know, there's too much to go in one webinar. We'll be looking at a lot of twisted box stuff. We'll be looking at sub-D stuff. We'll be looking at a lot of mesh stuff. Okay, those are like the kind of three main places we'll be today. And other than that, all good. So before we actually get into it, some final information. Pufferfish, if you want to go back to it, there is an example file, so examples. I definitely suggest to check that out because I have an example for every single component, and also like different various, you know, workflow examples too. So, and they're all annotated and all that, so you can learn a lot from those examples. Put a lot of time into that. And then the other thing I just want to mention is on our websites, there's a resources category. Basically what we've done here is our team, who's very experienced and have been through all this before, has collected, you know, what we consider to be, the top kind of free intro webinars throughout the web, mostly on YouTube. So if you're getting into any software, I suggest no other, because then you'll just get confused with there's a lot of clutter out there. There's a lot of webinars that aren't really, you know, from an experienced Grasshopper user point of view, they're not really teaching it correctly or not using lists correctly. So these are all you can't go wrong with. The best of the best, Intro to Grasshopper by Node Lab. You can't go wrong with that. It's from 2015 and still, in my opinion, the best Intro to Grasshopper course there is. Bifocals isn't necessary. It's just for me because it's for me to teach you because it puts the names of the components above. So you don't really need it. But if you want it, you can get it from Food for Rhino. That's all it does, is it just puts the full name of every component like above it in a bubble. Well, thank you. I'm glad you're enjoying the resources page. We put a lot of thought into it because we want people to have the right information. And we could have, you know, we were going between like, should we make our own? But we were just like, you know, there's good stuff out there if you know what you're looking for. There's no point to duplicate it. So we'll just we'll just list it. A lot of great education out there. Intro to Maya, intro to ZBrush, intro to Houdini. I've taken some of these myself. Like I've taken this one, Houdini Isn't Scary. I took this recently just as like a refresher. So yeah, definitely check all that out. And that's a good thing. Like, so you'll have the recording So what I want to say is if you're not familiar with Grasshopper, if you're feeling uncomfortable or behind, don't worry, you'll have the recording. And in this case, you'll have it to keep. You can go and do a whole intro to Grasshopper at your own pace if it takes you months and finish it. And then when you're more comfortable, you can go back to this webinar as well. Yeah, Long's C# webinar. Yeah, it's here. Yeah, it's really good. Okay. So let's get started. I'm just gonna turn off my camera just because it tends to make things run smoother. But I'm here. And if at any point something happens, audio goes away or screen share goes away, just let me know. I've been occasionally having some internet problems, but should be okay. Okay, so we don't need Grasshopper at the moment. We're just gonna look directly in Rhino. You can open that Rhino file or not. And what I'm gonna do is I wanna just do a little basic sub-D, which is just making this simple unit. Right? This is just like a simple sub-D unit. These units here, which look a bit more complex, these are all the units that I used for like the promotional material on the website. And that's kind of like what we'll get over. We'll try to do them all, if not step by step. I have also like put the steps, like copied them as I was making it, so you can see that. Or, you know, and you have the file too, so that's great. So the first thing is sub-D. Sub-D is a new type of object started in Rhino 6 as a kind of beta, and it's fully in Rhino 7. Still missing some important tools that I wish would be there by now. That, you know, makes some things a little bit more difficult that might be easier in Maya. But we're just gonna struggle through it and you know, have some fun. So I have some layers here. I think layer structures are very important. Base is like the base, and then there's like the host, which will be like a host file, a host that will propagate onto attractors and openings. I just marked the openings. You can see here in the polylines. And if you look in Rhino 7, there's a sub-D tools tab, right? Sub-D tools. So that's like all the new sub-D stuff there. All the new tools, a lot of fun stuff there. And now the first thing I want to note about sub-Ds is that they have two different modes. They have a smooth mode, which you see now, and they have like kind of hard edge mode. And so if you press tab, you can switch between those modes. Pressing tab will make every sub-D in the scene smooth or unsmooth. Okay. So again, that's just by pressing tab. You can see that it switches there, and you can see here where I have my openings. You can see how it's, you know, it's the opening of the unsmoothed version. Okay. What's under sub-D tools tab? Oh, that's just the filter. I like that. It's called selection filter. All right, so if I get it back, selection filter. When you first get it, it looks like a menu, and you can just like drag it up to here. That's all that is. It's just a filter. So it's like if I uncheck sub-Ds, then I can no longer like select sub-Ds, for instance. So it just lets you like make some types of things selectable and unselectable. Sometimes when you're doing like complex models, it makes things pretty easy. Okay, so let's start with this ball here. So I'm just gonna like model kind of like on the side here, just next to what I already have. And again, this is in the working file, right? So if you feel like you don't want all my junky modeling we're gonna do during the webinar, you can just grab the start file, which I won't be touching. It'll just be as this is. Yeah, of course it's not opening because you need Rhino 7, not Rhino 6. So First thing to do is create subd box. Just click that. And we're going to put X, Y, and Z count to 1. So you just click it X, 1, 1, 1. And then you're just going to click and hold. And I just typed the dimension. So you do something like, I think I did like 25 here. So like 25, enter, 25, enter, 25, enter. Made smooth. I mean, we can convert the smooth to straight, but can we convert something we made straight into something smooth? Yes, it's a subd. It doesn't matter. Like if whatever I do here, it's going to. It doesn't matter it doesn't matter which mode. In fact, I work between both modes. It depends like what I'm doing. Sometimes it's easier in the straight mode and sometimes in the smooth mode. Okay, so that doesn't matter. But for now, I'm just going to stay in smooth mode. So the next thing we're going to do is we need to get a subdivision like you see here. And the way you can do that is by using inset. So type inset. And you can just select the face, press enter, and it's going to ask you for the inset distance. And you can see like kind of outlines how big that would be. So if you did something like, I don't know, 15, you can see like it's got this like little small face there. Right, so something like 15 could be good. Maybe too small, but it's okay. Depends what size you're doing it. Maybe I'll do 10. Something like 10, right? Enter. Tab is to change the visibility, change between the modes. Tab, T-A-B. So just do that to like all the, oh, and sorry, if you hold Shift and Control at the same time, you can select faces, you can select edges, or you can select points. So that's holding Shift and Control and then selecting. I guess maybe that was what you were asking. So then Shift Control select the face, inset, and I'm just going to do that to all the previous faces. Okay, so now you should have something that looks like that. So now we want to get these like kind of coney things here. So what we're going to do now is we're just going to extrude. So what you can do is, in this case, select all of those little faces, the little inner ones that we just made. Like that. So just select those. Subdivide the surface. We're not subdividing a surface, we're insetting. Inset. I-N-S-E-T. Inset. So then what we're going to do is type extrude. Extrude subd. And you'll see it's like kind of giving you this thing. But we need to do a few changes to the settings. So we need to change it from basics WCS, which is World Coordinate System. We want to change it to UVN, which is the kind of normal object system. So now it starts to look like this kind of like weird thing like this. And you want to set the direction from free to N, which is normal. So now it's coming out like this. You have to select the faces and then type inset. You hold Shift and Control and then left click to select the face. And then so you just drag these out like that, right? So now you got like this little like spiky thing here. So then Shift Control and select, and we're going to select like these points, these faces at the points. And you're just going to delete. So now you're left with something like that. Okay. And The next thing I want to do is we can get it like a bit like puffy, like this. And what we can do for that is we can select, for instance, let's see how I like. Well, I guess it's a good point actually to talk about deleting edges too. Like that's important. So now, like, see these ring here. This is good. So if you click it, you can select one. But if you double click it, like click one, and then double click the edge next to it, and it will select like the whole loop of that edge. So I'm just gonna do that all around. So click one, then again you do Shift Control click, Shift Control click, and then Shift Control double click. So you're selecting all the loops around. I want that point. Okay. That. How did you extrude in all other directions? All right, and then just delete, and you'll end up like that. To extrude, you just, for instance, type extrude, change basics WCS to basics UVN, and change direction from free to N. Okay, so now you have this. And what we'll do is, like, maybe we want to get a base unit that's like kind of like more like sucked in like that. So we're just going to select the points now, Shift Control click, and click in like the inner. You can't actually see the points, but you can select them. So just like select it like the intersection of all those edges. And we'll get the 4 on the top and the 4 at the bottom. So you got those there. And then what you're going to do is you want to grab one of these, see these grips here, the box grips on the gumball. If you don't have a gumball on, it's down here. See it says gumball, just select gumball and you'll get like this like XYZ thing here. Select one of the grips, scale grips, which are like the boxes, and just like pull it. You'll see it does like this, but if you press Shift, you'll see it does it uniformly. So we can like suck those points in, something like that. Okay, so now you have this kind of geometry like here. And what we need in this case, like for our kind of base, is we need 3 different types of units so that we can, you know, create like blends and stuff between them. So we'll take this and we'll just copy it over. Let me just copy it. You can use the command copy, which is just copy. You can do it like in place, drag it, or you can use the shortcut, which is if you just select one of the move arrows, before letting go, hold down Alt, and then, sorry, hold Alt first, then drag it out. There you go. So that's a shortcut for copying. Just select it, hold Alt, and drag it out. Okay, this one will make like puffier. So let's just like select the edge, the loops around. And just drag it and hold space. And you'll make like can make like a fatter one like that. So now you have something like that. And maybe we want this fatter one now like with bigger openings. So this is one annoying thing with Rhino is we can't like scale locally. So we have to do each opening individually. So we just do our little double click trick there to get the whole thing. And what you're going to do is you're going to pull one of these, but then as you're pulling it, type the distance. So let's say like, what's the distance here? I don't know. In my case, maybe something like 75. And then before letting go, if you tap Shift, it'll do that. Okay. So again, double click, drag. Don't let go of the drag. Type the amount. It should be the same amount for each one, whatever you did. So that, and then press Shift and let go. Okay. So let me just do that real quick. What is the unit? This is a unit, I guess. I don't know what if that's what you mean. Okay. So then drag out, type distance, 5, go, here, drag out, and the last one here. So now you have your three, your 3 units. Yeah, if you meant file units, I'm working in millimeters. I guess with Command, if you even click on the square, you can input the scale factor. Yeah, I guess you can do that too, if it works with Shift. Yes, many things are built with sub-D tools. Okay, so now you have those 3. And you know that's basically kind of just a little intro to sub-D that I wanted to show. And then now what we'll do is we'll go into Grasshopper, and I just want to explain the kind of 3 basic morphing concepts. And then we'll get into modeling this stuff, and then we'll get into making the pufferfish, grasshopper definition to make towers with them. The links for the plugins that it's used. So we're going to open up Grasshopper. And okay, so, and this is, again, I'm working in the working file. So if you get behind, you can just re-download that file. Okay, so first things first is I want to show you the 3 kind of types of blending in Pufferfish, which is tweening, blending, and averaging. And we're going to work with meshes because meshes are just lighter to work with when you're doing stuff like blending and morphing. So what we're going to do is first get sub-D. So type sub-D, and there's a sub-D parameter. This doesn't exist in Rhinos 6, so you need 7. And we're going to get a component which is called, if you go to surfaces sub D, you can see like sub D components. It's called mesh. Sorry, we actually want the control polygon, which is going to give us like the hard edge version, right? So if I just do that, and I'm going to just set, for instance, this one here. So shift, right click, set one sub D, and we'll just set that in. And you can see there, right, it's giving us, like if I went here in Rhino and press tab, it's giving us like that unsmoothed version. Just hide that, right? Which is basically the mesh version. Okay. So that's what we're going to use, is those like unsmoothed versions. And I'll get another one. And I'll do this, and I'll do set one sub D. So now you have your 2 sub Ds set in there. And the first one we're going to look at is just called tween 2 meshes. So tween 2 meshes. And then it's asking for mesh A, tween from, tween to, and then a factor. So from, to, and factors are always 0 to 1. So by default, it's at 0.5. There's also colors for meshes. We're not going to do that here, but in the examples, you can see how if your meshes have colors, it'll also like blend between the colors as well. And we're just going to get a slider, and its default is 0 to 1. Right. So now you can see I'm moving from one unit to the other, right? So the important thing is that we made we made all these units from the same base, so we never changed the topology afterwards. So they have to have the same points, and if they have to have the same amount of vertices to even be able to tween or blend. And if you want a nice tween or blend, they should have the same like order of vertices. You don't want like this vertex blending to like over there or whatever. So that's another thing to keep mind of, right? Okay. So simple stuff. And actually, like if you come over here, we can actually just see it better, right? So if I just put some space between these. All right. So the next thing, quick one. Before we go to that, actually, since we're working with sub-Ds, if you wanted later on down the line, it'll be too heavy. But in this case, we can actually go right back. So if you do a sub-D from mesh, you can go right back to sub-Ds. And if I'll just get not necessary, but I like to use it for clarity, just another parameter there. Live video, don't worry about it now. It'll be, it's not a concern right now. So now you're right back in sub-D. So if I actually bake this, right, and go into tab, so now you have your blended like sub-D, which is pretty nice. Now, also, I know in Pufferfish, we're not using it here because I want to show the mesh part because we're going to be using meshes later, but there is also sub-D tweening components. You could tween sub-Ds if you wanted. Those exist there as well. But in the types of things we're going to do later, they can be a bit heavier. So that's why I usually convert to mesh, do all like the difficult stuff with the mesh, and then I'll go back to sub-D if needed. Okay, so next thing, I'll just copy this stuff down. So the next type of thing that I want to look at is blending. Or what does it mean like to blend instead of tween? So we're not going to need this tween, right? And blending what we want to do for blending is we want to have things like overlapping. So what I'm going to do is I'm just going to, for instance, copy these over here, and I'm going to put them on top of each other and make sure that the openings align. So I'm just going to, right? So they have the same openings, but they're like directly on, on top of each other. So that's the two things we're going to blend. And so we've got to set those in, right? So we'll set one sub D. I'll set like the inner one first, and then set one sub D, and I'll set the outer one. We don't need this slider. And we'll just get the blend to sub D this. Blend two, oh, sorry, blend two meshes. We're working in mesh. So you put A and B. Now you see the inputs look the same, but there's an important change in F, which has factors as list, where here it's just factors, right? So here we need to make a blend factor for each mesh vertex so that we can blend the vertices independently, rather instead of a tween, which is going from one object to another, blending goes from one vertex to the other. So you can have like more local control over the vertices rather than the whole entire geometry. So let me just put that there. So what we need to do is we need to get some values that equal the same amount of vertices that these meshes have. And if I come here and I get a panel, you can see it has 32 vertices and 24 faces, the mesh. We only need to measure one because they should have the same exact information in order to be able to blend or tween. Same amount of information. So we're going to get the vertices of one of them. Doesn't matter which one. So we're going to do a deconstruct mesh. Right? And if you see now, like there's points highlighted at all the vertices. So you'll get the vertices. And then what we're going to do is I'm just going to go here into my unit 0 attractors and just put a point down. Something like that. And in this case, we'll use an attractor. Don't have to use an attractor. There's many ways to get lists of numbers. But in this case, we'll use an attractor point. So we'll just get a point. We'll do set one point, and we'll set the point. Yeah, not answering questions for recording, just check the website. So then there's a point, and then what we need to do is we need to measure, so just pull point, and put it there, and then, so we're measuring from the vertices and pulling to this point here, to the geometry. You could also use distance, but I just got so used to using pull point because pull point will let you use multiple attractors if you wanted to. In this case, we're just using one, but you can use multiple points or curves. So I just basically use pull point for everything except instead of a distance, just because it can figure out multiple attractors. How can we get to know what to do when? You just got experience, just got to go through it, practice, watch the intro tutorials, watch this tutorial. You know, you need the vertices because you know that you need to measure the distance to them. So you get the vertices and you measure them to a point in this case. There's no like magic answer for that. You just experience and practice. So we're going to get a here in param util, there's a param viewer. And so you can see that this data tree has 32 values, right? Which is important because that means we have 32 distances and we have 32 vertices. So we know we're great. We have one distance for each vertex, which means we're good to go. But first thing we need to do is, if you remember, factors are from 0 to 1, and these distances are not. These are actually the distances from this point to there. So it could be like 50 millimeters to there, 80 millimeters to there. So we got to get those to be proportionally to 0 to 1. So you can use in Grasshopper remap, which will let you remap a number set to any other values. But in Pufferfish, I made a nice little reparameterize. So when you make anything to fit between 0 and 1, it's either called, there's two terminologies. They mean the same thing. It's either reparameterize or normalize. Depends which software you're using. Like things like Houdini, for instance, tend to call it normalize. Grasshopper tends to reparameterize. But that's all it means is it's going to fit these numbers. So you put the numbers in. It's going to fit them proportionally so that they're between 0 and 1, right? So you can see now the list if I compare them side by side, right? So they're same proportional distance between, but they're just between 0 and 1. And the nice thing about reparameterized numbers is it also has a Boolean to invert the remapping. So you can remap from 1 to 0 instead of 0 to 1. So we'll just get a Boolean toggle. And when I toggle this, you can see the numbers change there, right? So just flipping what it's remapping to. So those are going to be now our values into F, right? So if I go and hide these real quick and preview the sub V, you see you have a shape like this now, right? Because of the attractor, it's more like this shape on the side closer to the attractor, and then more like this shape on the side furthest away from the attractor. So if I move this point, this attractor point, to the other side, it's going to do the opposite, right? Okay, so that's how you kind of blend two shapes together to get some of this shape, some of the other shape into a new shape. How do you line? Just snap them, just put them over on top of each other. Just copy or move, whatever you want. Just put one on to the other. Just move and then. No, you can't use tween instead of blend. I actually just went over what tweening is. Tweening is the whole object. Blending is the vertices of the object. Closest point and pull point in this instance. Pull point will let you use, it has a closest option, which will figure out multiple attractors. It will also let you use any geometry. It can be points, curves, geometries, a mix of them, doesn't matter. It can be any geometry. Can we convert? You can what does the point define for blending? It's an attractor, so it's just distance. You're saying if you know how far you are. So the distance, I get line from the attractor to the vertices. You can see there. I just put a line so you can visualize it. So it's just saying the closer it is to be more like the first object, and the further the vertex is to be more like the second object. So as I move that around, you can see how that happens. Unable to find blend two meshes. maybe you don't have Pufferfish 3 installed. It's only in Pufferfish 3. It's not in any other Pufferfish. So make sure that you don't have like Pufferfish 2.9 or something. And it's in mesh, Pufferfish, mesh, blend. Meshes. I'm not going to answer any questions about the recording because it's on the website. And if I do answer it, I'll answer it all day. So just read the website. It's there. Blend to meshes, yes. For sub these surfaces, can't find the blend to meshes. Pufferfish 3.0. For sub these surfaces and volumes. For sub these surfaces and volumes. It's not for volumes of sub D. What about different sub-Ds with different number of vertices? Not easy to do. No one really does that. It's just not industry standard. Even like the top animators don't do that. You make a mesh and you change the mesh vertices. However, there are some tricks you can do. I have a file in example files that you can check out. Did you say blending is for vertices? Yes, blending is for vertices, tweening is for geometry. Just answered that. The difference between tweening meshes and blending meshes answered. Mesh A and B require the same topology. Yep, that means that you don't have the same topology. You have different amounts of vertices in your mesh and your sub-Ds. If you model them as I did or use the ones in the file, you'll be fine. Okay, so there you go, a blend. So actually, if I just separate these, you can see it'll get weird, right? Because it's gonna, so that's why usually with blending, they're on top of each other. You can also tween on top of each other, that's fine too. But if with blending, it's positional, right? So it's trying to, based on the attractor, it's trying to be like more like that shape all the way over there, and more like this shape all the way over here, because it's using the vertices to try to blend between those vertices. So that's why usually with blending, usually things are on top of each other. Okay. If anyone doesn't know, I just lock these. If you open a file and it looks like this, you just do this middle mouse and then you can like hit this enable and that turns it on. But I just disable it because we don't need to compute that right now. Once we're kind of looking at it for a moment. How did you soften the mesh and turn the edges? Rhino. Press tab. Okay, so the last one I want to look at, which we're just look at here, but we're not going to we're going to look at these two more in depth for the main parts of the webinar. But this one, the next one I want to look at real quick is just weighted. It's just another thing. So if you go into mesh and see there's like this weighted average, right? So what weighted average does is if I take, for instance, these three here, and I just like position them around, let's say something like that, something easy to visualize. So say you just have like three things like that, you'll get your same sub D, okay. And we'll, in this case, you do set multiple sub Ds, and you just one, 1, 2, 3, select them, hit enter, so that they're all set. All three of them are set in there. Okay, and no, you don't need to graph to flatten anything right now. So we just put those in, and basically it needs a weight. So you're basically going to give each object a weight, each geometry its own weight. It's going to be like the percentage of how much like of that object we're going to use. So you get some sliders, and you need 3, right? It'll throw an error, so you have 3 because we have 3 objects here. So if I put 1, it's going to give me an error. Multiply equal amounts of weights to meshes. We have 3 meshes, so we need 3 weights. Press Shift and drag this in. Press Shift, drag this in, right? So now what we can say is like, well, maybe we want like less percent of this shape, more percent of this shape, you know, and we want more of that shape. So now you're actually blending, you're not tweening between the 3, you're actually blending the object between the 3 and giving it like weight. And I like to visualize it in like something like a triangle, so it's easy. You can see like where on the kind of map of blend it would be between those 3 or more objects. It could be as many as you want, as long as you have a weight for each one. Okay, so that's just the simple simple other type that we're not going to use right now. So while we're here, I want to take a quick other look at this to say, you know, so here we did a factor, here we did a list of factors, and I just want to show what happens if you do a list of factors here. So I'm just going to copy this whole thing over. And I'm going to go turn that on. So that was, you know, blending, tweening between these 2. Now, instead of a thing, instead of a slider, you can use an entire list. So the way we can make a list in this case, I mean, you can use attractors, whatever. I'm just going to make a list with a range component, which is just going to give me, its domain is 0 to 1. So it's going to give me a bunch of numbers between 0 and 1, and I can set how many numbers. So I'll just get a slider. And I can just plug that in. Right? So now you have 10. Right, so now you have like, you can get all like the tweens between those tweens between. And another quick thing you can do, which I do a lot, is use a graph mapper. Since it's 0 to 1, it's easy to use a graph mapper. Just plug it in, right-click the graph mapper, graph types, and select a graph. Most common is Bezier, and plug that into the factor. So what that lets you do is now you can, instead of just directly going step by step by step, you can actually, maybe you want like more in that direction or more in that direction. So you can blend like that too. But the components I use the most aren't the tween to, but more the tween through. But they require a bit understanding of like how lists work. So if you're more comfortable with 2, but by the way, the tween through components, THROUGH, are actually faster than the tween 2 because they have to calculate less times over. So if you were looking for some speed, you would use like a tween through. So I'm just going to grab one of these. So just grab one of those. And in this case, what I'm going to do, I'm going to turn this one off. This one off. In this case, what I'm going to do is I'm going to set all 3 of these. So set multiple sub Ds. 1, 2, 3. Because with tween through, you can do more than 2 also. You can do 2 if you want, but you can do more than 2. So tween through meshes. And you just plug all the meshes in there. And M is a list of meshes. Default 0.5, so it's going to show this one because that's like the halfway mark between those 2. And then it needs a factor as before. So, you know, if I have a factor, now I can blend sorry, tween like between those three objects, and like 0.5 would be this geometry, the middle geometry. But if I, if I move this, whatever here, right, it's gonna. And just as before, I'll just grab this. We can also do this as a list. Do a list like this. Have all the blends there. I'll just set this back to default for a second. There you go. And then, tween through has some nice options. You have an equalize. Let me get some Boolean toggles. Boolean toggle. You have an equalized option, which you can see there's like a little bit difference there. Basically, it's just like equalizing the distribution. So like if this was more, if you see this is like more here, like it's tighter there and there. But if you do this, it's going to like more equally distribute across the whole system there. We have weighted. So weighted won't do anything until you'll see it gives you a message like that. Kind of a weighted distribution requires a path with curvature. And the way we can do that is with this degree and interpolation type. So default, it's interpolating linear. So it's going linear from 1 to 2 to 3. So you can see it's linear like that. But if I get a slider and set the interpolation type to maybe something like uniform, you can see that like kind of curved out. So now it's got like a more of a curved interpolation. Right? So again, like you can see how that's changing, right? And then the weighting there is gonna like basically weight the distribution based on the curvature. So you can see it changes a little bit in that case. And then the new option in Pufferfish 3 is the loop back option, which basically gives you a nice way to complete. You can do a tween that goes, and if you're using curvature, obviously the curvature is going to change in that case. But if we look at like this, like, so you see what's happening there. So it's going to make it be able to tween back to the first one. No, I won't share the file out in lower Rhino because it won't open. This file will only work open in Rhino 7. If you try to open it in anything else, it's just going to throw error. Even though 6 has subds, it won't open the subds from 7. That's why we mentioned like you should use 7 probably. Okay, so now that we have that, let's save for you if you want to grab these files. Okay, so now that we have that, let's look at I want to look at a basic morphing to twisted boxes, because that's the other part that we'll need here is how to morph to twisted boxes. Then after that, we'll get back into sub-D modeling here, and then we'll get into the last Grasshopper definitions for the final stuff here. When do we use blend mesh blend? They both require meshes of the same topology. Yeah, so use tween when you want to blend like from object to when you want to go from object A to object B. Use blend if you want to mix object A and object B. So if you want to mix them together, blend it. If you want to, create a shape that's between two geometry, like from geometry A to B, use a tween. So next thing we're going to do is we're going to look at the basic twisted box setup. So come back over here and just going to look at these geometries here. They're the same geometries I made, but I've just set them up ready for this. So one for tweening is just that small and inner shape overlap on top of each other. So I'm just going to go to my host. Host will be like where we're hosting these things, where they're going to propagate. And I'm just going to make a surface, any surface, something like that. So that's here, that's a rectangle plane, corner to corner, or just type plane as the command in Rhino. And just draw it. Size, the sizes, it doesn't matter, like just whatever size is fine. Can be something like that, and we'll definitely need an attractor. So I'm just going to drop a point like over here somewhere. And what we're going to do is make the sub these. So make the twisted boxes. So Pufferfish has this whole tab of twisted boxes, and there's just tons and tons of ways to make them. We'll definitely will not cover most of these, but there's examples for all of them. In the end, they all result in a thing you can use as to morph into. They're just all different ways to make them and design them. In this case, we're just going to put it on a surface. So if we go and we search twisted box surface, twisted box surface. Just drop that here. And we're going to get a surface parameter. Set one surface. And you'll see that it put like these boxes there, right? We need a thickness, so that would be like the thickness of the boxes. Overall thickness. So now you'll see as I bring that up, let's just so you can see how it's making these kind of like wireframe looking boxes there. And then you have UV and W parameters, and that's going to be the division parameters. It's not division count, it's parameters, so that we can be more flexible with it if we wanted. But we're basically taking that same setup where we're getting a range between 0 and 1. So that's just set max to 25, something like that. So that's going to be the number, and then we just put that into U. So you see, like now there's 25, divisions on the U axis of a surface. You can do the V. That's probably, for what we're doing now, probably like too much. Something like that, just more manageable, maybe even less. Something like that. Yeah, something like that. And you'll see there's a height, there's boxes in the height too, which you change for W. W is surface height, typically. So you can see it's making more divisions in the height there. For our uses afterwards, we won't need multiple heights. So a little trick with Pufferfish, if you just want one, if anything asks you for a parameter, and you just want one like division or one thing, you can just type 1 and plug a 1, right? So that's like a little secret hack with Pufferfish, is if you just put the number 1 into something, it will give you 1 of that type of thing, 1 of that parameter, rather than having to write 0 to 1. So that's a little trick you can do. In this case, we'll just keep it like this for now. And the other trick you can do is, just as we did up here with the graph mappers, you can do the same idea. And that's the idea of Pufferfish. Pufferfish, unlike Grasshopper, which uses mostly like divisions for stuff, uses always parameters. So if I get a graph mapper, get a graph mapper, graph types, NCA. If you put a graph mapper in anywhere, you can change to be non-uniform, right? So the divisions don't even need to be uniform. And that will work for V and W as well. But for now, I'm just gonna stay like this, but I'll just leave it off to the side there if you want to use it. So what we want to do is we want to put these into here, into like basically put the geometry into there. It's very straightforward. If you just want to put one, right? So you can just get, let's get our little sub D to control polygon routine here. And if I just set one of these, like, let's just say this inner one, set one sub D. And I just go to, we'll get a morph to twisted box. You can also use box morph, which is Grasshopper's native, but mine is basically, it's the same thing, same inputs, but it's multi-threaded, so it's a lot faster for this kind of stuff. So you get the sub D, that's gonna be our geometry. And then the references, we need a reference box and we need twisted boxes. Well, we made our twisted boxes here. And the reference box can simply be a bounding box. It's going to morph. It's going to morph from this box to the twisted boxes. So we put this there, and you have your box. Put this here, and now you have those all in there. Right? And I'll just preview that. So you can see it easier. Right, so now they're all in there. Alan always does here. Yeah, it's a nice little trick there. Basically, if the text that you just put a single number, it's just gonna go 0 to that number, like in the code. I also got tired of putting 0 to 1. Yeah, per object is if I had 2, kept it per object, it's going to get each object a bounding box. If I set it to union, it's going to make them both in one total bounding box. That's the difference. And we'll use union later. So that's that. But it's not really, actually, before we move on, where can we apply this technique in design? Anywhere you desire. Just use your imagination. It could be anywhere. It could be a structure, it could be a lattice, could be anything you want. So now what I want to explain to you is the relationship between bounding boxes and this box that they're going into. Okay, so if I get a scale component, scale, and I scale this bounding box by its center, so we'll just get the volume. Center. So we're going to scale it by its center. And it's default to 0.5, that's why you can't see it. It's like kind of hidden in there. But if I just hide this real quick. You can see there, right? And I'll just get a slider that goes to like 2 or something, or more, whatever. So if I go to 1, which is no scaling, scale factor of 1, which is just the regular box, and I use that instead of the reference. So you'll see what's happening is it's exactly fitting this shape, and so these shapes are exactly fitting in those boxes. But if I scale this down, you'll see all those get bigger, right? Because the relationship of our unit to the box is that the unit sticks out of the box. So that same relationship is going to get morphed back into these, right? So they're going to stick also out of the box, proportionally the same amount in the morphing. Same thing if I bring this bigger, right? So now the box is way bigger than the unit, and in that case also the box is bigger than the unit. So that's the relationship between the bounding box and the twisted box. But 1 will suffice for now. But that's a little bit boring to just use 1 unit. So let's, basically we're going to look at like what does it mean to place blended units there. Why do you always make the output to a mesh? It's just habit. I just find it cleaner when you want to use things downstream. You don't have to. I just find things like parameters, same thing here. Just find it cleaner to work with. So you don't have to, just I think makes it cleaner. What sub D input did you give it? I'm getting a different shape. I just gave it one of our sub D units, any one of them. Okay, so what we can do now that we understand that relationship of the boxes, this box is like, let's blend some stuff in there real quick. So first thing we need to do is, just like we did with the one over here, like we were blending a mesh, we need to get some distances. So what we want to do is we want to measure from this point, from any attractor point to the center of those boxes. So we get the tween value of each geometry. So how much tween like each geometry should be per box. So we're going to get a deconstruct, oh, sorry, not deconstruct, twisted box centers, right? So if I just, let me just turn off this preview real quick. So now you have a center of every twisted box. Okay. Also Pufferfish component that just calculates fast. But this component in particular, be careful because it outputs as individual lists, because it does potentially have, it has the potential to make things that need to be in a list like that. So I always flatten it in this case, because it can also do edge lines and face polylines. So we're not going to use them, but for instance, if I wanted the center of each edge of each twisted box, so like now I have all the centers of all the edges, but they should be grouped by twisted box. So you can see here, they're like 12 points per twisted box, right? So that's so that n equals 12 is like 12 points per twisted box. And you can also do the same for faces. So this will give you the center of each face of each twisted box. So now they're grouped by faces. But we don't care about that right now. We're just doing only the center, like the volumetric center. So we'll just flatten this so that it's all in one list. Okay, so now that we have that, we're just going to do our pull point. So pull point. Pull point. And we're going to pull from those points to an attractor. So we'll set one point. So now you have your distances, and it should seem pretty similar to what was happening before. We basically need to get like this kind of what we were doing here in the, where was I drawing it? Here. What we were doing here is we got to reparameterize. Right? So we can just do reparameterize the distances. So they're 0 to 1. And for a little bit more fun, we'll put a graph. And I'll just put it to Bende. So now we have all those distances. And what do we do with them? Well, what we want to do with them in this case is we want to tween with them. So we'll just get our two what do you call two things we want to tween. In this case, and in this case, they should be on top of each other so that we can use one bounding box. That's why here I put them on top of each other. So we'll just set one sub D, then set one sub D. Okay. So now you have your two sub Ds converted to mesh. So this off. And we're going to tween two meshes. So tween two meshes. A. B. And what we're going to use as the factors are these distances we just measured. So if I hide this, you'll see that there's actually like a bunch of tweens all overlapping. That's like the whole sequence of tweens in there from that. And then we're basically going to remove the correct tween to its position in the box, to its correct box based on that attractive distance. And so the way we do that is that. We have our morph to twisted box here. Just trying to make it more organized. Okay, so now you have your stuff there, and what we need to do is for the bounding box, I like to use the naked edges because I know that those should match up, and it's just a way to guarantee that I have the same bounding box relationship. So I just get the curve component and set multiple curves. And if you see the one I drew here in the example file, I basically just traced the openings, and that's what we're going to get, like those pie lines in green that I've drawn, and that's what we're going to bound. We're going to bound those. Okay, so you have those, and then enter, and that's now you want to set this to union so that it gives all of that one box, right? It's just a way. I just use the good practice. I just use the naked edges there just to ensure that my box is the same for both, because they need to have the same naked edges so that they can connect to each other. That's what's really important. So now what we do is we just plug this. Let me just save for you guys. Save. And what we do now is we put that here. So if we go look at our thing here, so you can see now how based on the distance to that attractor, you're changing the size. It's because you're just basically changing the tween based on a distance. Okay. And then you can, play with your graph. Like if you want the fall off to be different, you can like, play with that as well. I don't know. Is anyone else seeing a lag? I don't think there's a lag. It could be like dependent on like what your internet connection is as well. It really depends on your internet connection. Is anyone seeing it fine? If anyone can answer. Anyone seeing the video fine? I think if there's a lag, it's your internet connection. The wonders of Zoom. So yeah, so now what I want to talk about is like if someone was asking before, why do I use whole points? Is because you can use multiple if you want. For instance, if I wanted to use multiple points, enter. So right, like so now both points are attractors, and so like you're small there, big in the middle. Or you can use even a curve if you wanted to, or curve endpoints. Really, you can use anything with this component. Set one curve there, and then so now you can use a curve as well. But I'll stick with the points, and I just can use 1 point just because I think it makes it easier to explain. Let's go. Set 1 point and put that in. And like the reparameterize, remember I said you can invert. So like that will actually just invert the operation, the effect there. Now the important thing, like why, in this case, because we're going from object to object, do they need to be exactly without each other with the same openings so that when they're together, they still connect? See how they're connecting? I didn't set 8 or 4, I set 6. There's 1, 2, 3, 4, 5, 6. There's 6 openings, or 12 if you're doing both. Can we replace points with curve? Yes, I just did that. Is it possible to use boxes on a chimp surface? Yeah. It won't follow the chimp surface, just like any division won't, because there's no specific way to do that. When there's a trim surface, you have to think about the design. That's just general rules. Because there's a billion different ways you can decide to resolve that trimmed edge. So no component is going to really figure that out for you. How did you select curve? Green. Yeah, just set multiple curves and just select them. 1, 2, 3, 4, 5, and 6. That's it. Are your top set meshes and bottom set meshes connected to the surface? They're going along. I mean, the surface is just the host of the twisted boxes. That's all it's doing. It's just a way to create the twisted boxes. Yeah, it can be applied to anything. It's just a surface. You can do whatever you want. I just rebuild this and that's it. 10 points. Just make this one curved. There you go. And of course, you can go all the way back to the beginning and put more or less. But this is just for example. It's not really the point of this webinar. It's just to explain the two types of blending, right? So that's the tween type of like twisted box propagation. Openings joined on top. They should be exact. If you have a gap, it means something is off with your modeling. Something's not symmetrical, or your bounding box is incorrect. Just double check your modeling. Or download this file if you want. Okay, so last piece of information before we get into the sub-D modeling, and then the main definition. So the next thing I want to show you is this system, but with the blend meshes, because blend meshes, unlike the tween meshes where the connections need to be the same so that they meet up, with blend meshes we can have different sized connections. Actually, let me turn off my mesh. It's easier to see stuff. Not so much easier. You can always go into like Arctic mode if you want to see things like something like that. Easier to see maybe. Yeah, but it's hard to work in that mode. So, okay, so let's just take this and copy it over, and we'll just like pull it apart and add some stuff. We need a new surface and a new attractor, so I'll just Alt drag those out so we have them for this too. And I'll just set one surface, and I'll put this point in here. Okay, so what we want to do in this case is a bit different, is we want to morph everything first and then blend between the meshes. Morph to it. You cannot supply more geometries than target. Yeah, so it's pretty self-explanatory. You can't have more geometries than twisted boxes, means that you have more, like something's wrong with your data structure. Maybe you didn't flatten. My guess is you didn't flatten this. That's my guess. I don't know where you want me to zoom in the Grasshopper because we have to like work around, but you can also download the file. But yeah, my guess is if your error is that, because it's the only thing I could think of that we changed the data structure, is that you didn't flatten this, the twisted box centers. So try that out. Okay. So now that we have this, so in this case, we want to morph first. So we're going to get these, we can get rid of the tween. In this case, we don't need that. We don't need the twisted box centers. Control and drag to unplug. Yeah, okay, so the gap was because of the scale factor. That makes sense, because of proportional issues. Okay, so first thing I want to do is I want to get these two into separate lists, and a way I like to do that, there's many ways. You can like put them both in parameter and graph, but I like to use entwine. I just find it neater. So entwine is basically, if you see there, it's like each one's in its own list. It's the same as like getting a parameter, let's say like this, and then grafting. I just find this more self-explanatory, and I can see the order that I've inputted in. So entwine that so that they're in their own, their own lists. And we're going to morph first. So morph to twisted box. And then what we're going to do is we're going to use these twisted boxes. And our reference is going to be our sequence of things here. This here. Again. So that's going to be, again, our reference box. Okay, so everything went there. Perfect. So what happened now is, if we look at this data, is because we put in two separate units basically grafted in their own lists, and we have one reference box, and we have 108 twisted boxes, but the twisted boxes are in a flat list. Here, they're in a flat list. So it's going to basically take all this unit and put it in all the boxes, and then it's going to take the second unit and put it in all the boxes. So that's why we needed to get this data as them in their own list. Again, if lists are difficult, if you're a beginner, if you don't understand it exactly, it's fine. It takes time, and that's why you should practice. But the important thing, though, is that we put each unit, one unit in all the boxes, and then the next unit in all the boxes. And you can see it there. They're like overlap. There's two units basically in every box. And we're just going to join mesh and flatten. So now you'll have two meshes only. And I'll bake this real quick so you can see what that means. Bake it on a layer if it's not red so we can actually see what we're doing. So you have two. Now you have two things there. So we made this one. It's all the same unit, all unit A. And this one, that's all unit B, one mesh, two mesh. They'll have exactly the same vertices. And what that means is that we can blend from one to the other, just as we blend a simple unit from one to the other before. So we only need to measure to one of these meshes vertices. So we'll just get a list item. And we'll get the vertices. So this should look familiar from our example earlier, this one here, the blending. Like that, and there we are. So list item, and then we're going to deconstruct the mesh. And get the vertices. Only need of one, that's why I did list item, just one of the meshes, one of the two. And we're going to do our pull point here. So we're going to get this operation that we had before. But now we're going to pull, we're going to measure from this point to all the vertices of the mesh. Again, if we visualize that like we did before, you're going from like that. Right? You can see it with these lines there, right? You're measuring to every vertex of one of those meshes, those joined meshes. And now we just blend. Click blend two meshes. And we'll want to, I'm actually going to get this here, right? So if you do list item and do plus, you'll get both of them separately. And we'll go from this joined mesh to this joined mesh. Again, this joined meshes vertices to this joined meshes vertices because it's a blend with this factors. And put that in here so you can visualize it. Just unclick this. And there you go. So the difference between those two methods is really how you want your connections to work. So if I look here, if I go to Arctic mode, you can see it. So here you're scaling small to big, but in the tween method, your connections need to be exactly the same. So you'll see here and here, the connection is the same. It's just like the other stuff that gets bigger. Because if you tween the whole geometry, then you'll have a bigger opening here next to a smaller opening, and they won't connect together. However, if you do it this method, where you're first creating an entire mesh of unit A and then an entire mesh of unit B, and then blending those units, now your connections can, which like, oh, you know what it is? I didn't change the units. So make sure you're using the right units too, because you see I'm still using those units. So you want to use these units here. So that's fine. So set one, use that, and then for here, set one, use this one with the bigger openings. So now, there you go. There we go. So now you see like the openings are bigger too here because they can be blended in that way. So that's the difference really between those two methods. Let me save these. Turn off. Why would bifocals affect what the inputs and outputs are? Bifocals is creating this tag up top. Is that affecting something with inputs and outputs? I don't understand. That's one. So while we're here, I think this is a good stopping point for a break. So let me I'll leave this up here. But also download the file. Sizes per object need to be the same. They need to be the same for the tween method. They don't need to be the same for the blend method. However, in the blend method, they should be on the same, like the same plane, or same relationship in the twisted box. So if it's tween method, it should be the same so that they connect, because when you're blending object to object, you need those to connect. And if it's a blend method, they can be different. What are the curves that go into bounding box? Oh, good points before we stop. Good call. That's why it's like shifted off there. Yeah. So also got to replace those curves. Set multiple curves. Those are just what I'd use to mark the openings. In this case, you can just use the bigger ones openings. I just drew them, so you can just draw them if you want. I drew them in the file that I gave you. I could just trace the openings. So yeah, replace those so that it sits properly on the surface. So that's what those are. They're just the openings, just a way to mark the openings. Seems my thing did something weird. Okay. So let's just leave that there. Now these are saved. So if you're behind, go download them again. I'll put the link here again. And I'll leave this on screen. I put the link there, so please download it if you need. Um, and why don't you just we'll come back in 10 minutes. So at yeah 10 minutes. So if you want, take a break or play around with that for 10 minutes, and I'll see you all in 10 minutes. Okay, I'm back. I cannot provide these files in Rhino 6. They will not work in Rhino 6. They just won't work. Building one good design of Pufferfish. That's not that's area source for 2 by my channel basically are covered. I don't just I mean it's just kind of understanding how things connect. That's why Mesh Plus is kind of nice because you has some units that you can make by default. But yeah, I mean, it's just like, just think about a tile and how things connect. You can use Pufferfish and Grasshopper in 6, but you can't do the sub-D stuff really, because sub-Ds are limited in Rhino 6, and you don't have them in Grasshopper for Rhino 6. Can't work out the difference between the two versions. To me, the main difference seems to be the fact that we've referenced a different sub-D model for each version. Can you quickly summarize again? Yeah, I mean, it's okay. So one is object to object. One is objects vertices to objects vertices. Okay, so how can I, if I quickly go back to our thing here. So if I put these back, like if I put these on top of each other. Okay. And then I do the same thing. Okay, so you have these next to each other, right? You have, here's the tween version. Here's the blend version, okay? So let me hide this. So if I'm tweening, right, I'm tweening one object completely to the other object. It's the entire object, okay? So like the exact middle between those two objects is that, right? What blending does is it gives you control over the vertices. So instead of the entire object, you're blending the vertices. Okay. Now I could essentially, in this case, if I just put that, it's going to make an entire list of that number. It's going to be exactly like the tween, right? It's literally the same thing if I just use a single value. But that's basically making a list of whatever 377 for every vertex. But in this case, I can do like what we did here with the attractor values, and that lets me give a different value to each point. So imagine this is like tweening the vertices, and this is like tweening the entire object. That's the difference. Yeah. Okay. So on our website, you know, like we mentioned the software to use, and we do that on purpose. I mean, we're not trying to trick you. I memean, we wrote Rhino 7 because we need Rhino 7. Otherwise, we would write like Rhino 6 or above, or you know. So you can't use Rhino 6 for this. You just can't. Just get the evaluation of 7. Okay, let's put away Grasshopper for a moment and get back to our file here. And let's look at making, for instance, this unit here. So I'm just going to go into 3 mode here. Not 3, that's my tab. It's tab, so we get the smooth mode. And, you know, I just want to stress the importance of playing around with this stuff, because it doesn't need to be exactly what I did. I also mess stuff up all the time. It's okay. Like, you just gotta work through it, you know, and play with it and see what kind of stuff you get, to go basically from this to something like this. Okay. It's just all about like playing. There's no science to it. So what we'll do is we'll first start with a sub-D box, and we'll go like, what did I have here? 3 and 3 and 3. So just set everything to 3. 3. And just like drag that out. Doesn't need to be exactly the same, whatever, something like that. Okay. And what I like to do when I'm modeling, yeah, please, which means what? Yes, please to what? Okay, so when I'm modeling, I like to copy it out in case I need to go back or I make a mistake and I go too far and I don't like something, I don't have to go all the way back to the beginning. So I'll just like copy this out. And so that's what you can see here is like my kind of design process, which I saved there. So next thing we can do is we can, for instance, we can do what's called bridging, right? So shift click, we can select here, and then we can select exactly on the bottom and type bridge. And that's gonna like kind of blow a hole through the center there. And you're gonna get a bridge. Okay. So it's basically just bridging between those two faces, and enter. Now we have a bridge. And actually, it should give options. Let's see. My menu is off to the side here, I think. My menu is off screen. Here it is. So it brings up this. This is like number of segments. If you want more segments, if you want it to be a creased bridge, so it's like sharp, or your straightness. If there's more segments, in this case, I'm just going to leave it as default. Hit enter and make the whole again. Shift control click, shift control click, type bridge. Okay, that's how you make it. Okay, so next thing is we can extrude this. So if you do shift click, now if we're just extruding a single face, before we used like the menu extrude and then we set it to normal, that's good if you're doing like many things that need to go in opposite directions. But when it's just one, if you actually just drag this up and tap what is it? I think we just press hold. There you go. So if you hold down control, you'll see it like switch to like extrude mode, right? So just hold down control while you're dragging and it'll like extrude up a bit like that. So you get something like that. And then I'm just going to like scale this. So I hold shift and just like scale it in. And we can extrude, and we can like just play with this. And you can see like I did like something like that's like coming like this. And then we can even make this smaller. And then we'll extrude again. So pull up and then just hold down control. And you'll get like a, and then just like, just play with that. Just position it. Something like that. And then delete that end gap. So now you have something like that looks like that. Right? Cool. And then what we can do is we can maybe like thin this thing out a bit. If you see, I had it like thinner there, so I'll just like double click this whole loop and drag that up. Then also double click these edges and bring that up. Make it, just to make it like a bit thin. Actually, I want to select the faces on this one. So just select these bottom faces. And just drag them up. Just make it a bit thinner. Give it a little there. What is extrude again? Yeah, so just select the face, pull it up, and hold Control while you're pulling it up. So now I want to select like this corner. So I'm just going to select everything in that corner with, again, Shift Control. And I did something like that, like just like moved it up a bit, just to give it some movement. So the next part is the kind of important part is we need these openings to be flat so that they fit into the box. We also need them to align on top of each other. So what I do is, first of all, I should be doing that in base in unit 1A. So I'm going to model in base unit A. And I'm going to get my openings layer. And I'm going to go into the tab. So we go into straight mode. Basically what I do is I'll just draw a polyline on this edge. If you don't have your snaps on, go here, snap, and turn on end points, points, and vertex. How to select multiple edges at the same time. Shift Control, double click to get the whole loop. If there's no loop, it'll just select the one. Like if there's no obvious edge loop, it'll just try to get what it can. Okay, so you have that, but we need to make sure it's flat. So what I do is I do project to C plane, and yes to delete. Yes, and you see it like projects it to the floor, and then I'll just move vertical, and move it right back up. In that case, we got kind of lucky. But if it wasn't, like, let's say you traced this and it was like, just turn your points on, you can type points on, or you can press F10. Let's say it was something like that, just for the sake of showing. So I'll just put this point here. So say it was like that. What I'll do is I'll just do project to C plane, yes, and then move that up vertically, and then just fix this point on so that this goes there. Okay, so that's flat. Press tab to go between the two sub D modes, straight or curved. Okay, so what we want to do is now, like, I'm just going to copy this because it's going to be like the target for our like bottom one here, because we want them to align on top of each other, like when we want to stack them. So I'm going to go back into this mode here, tab, and this one I created like I started extruding from like this face here. So I'm just going to pull it out and hit Control, so we get like an extrusion, something like that, and I'm just going to pull it down. And then you just like kind of play with it. Actually, easier way would be just extrude out, scale it. Normally get the face smaller, then bring that down, that, and just delete that. All right, so you have something like that, and then you just manipulate it so that it's like a bit more nicely shaped. So this edge, that. and something like that. And then again, extrude and something like that. Okay, and then what you do is you go into tab mode and just snap those vertices to this rectangle that you put on the floor there. So if you do points on or hit F10 and then just move the points to snap to the reference rectangle there. Tab again, and you have something like that. And then you can shape this up. Like it looks like I had this like a little thinner. Maybe do more swing, something like that. I kind of want to make this fatter. Yeah, so just just playing with the model. So the point of that, multiple UV surfaces, like yeah, you can do subdivided and all that stuff, but we don't need it for this right now. So the point of that was that, so if I took this and copied it and went vertical, they will be able to stack exactly on top of each other. So those will like line up, you see? That's kind of that's the goal. Right? And so like when you join those, if I joined them, and in smooth mode, when I join them, you see how it joined together smoothly, right? So, but we're not joining them right now. Just wanted to show you why I use those reference rectangles. How to add segment on that area only or on that part. I'm not really sure what that means. Okay, so I'm just gonna copy this over again. Here's over here. And I had like two more. I had two more openings, so I'll just make those. And again, now, so what's important now is that the openings should be at the same height, right? So that the bounding box hits it correctly. So I'm just going to grab this and extrude it up. Something like that. And then I'm just going to move vertical to make sure it's exactly aligned with that. And then you can just move it this way. So that's something like that. Okay. So the important thing is those are at the same height. And we'll do again tab, and we'll just trace this. So now we want to be at the same height as that one there. So now we have a reference. It needs to be the same height as this and in the same position projection, let's say, as that. That's kind of like the way to do that. Let me just save. So now what we can do is we can go back. We can select this one and we can extrude this one. And then, like we did before, just align those vertices. So points on. I usually use F10, but I'm using a keyboard right now that the F keys aren't set up properly. So I'm just typing points on, but you can just use F10. Okay. Tab. Right. So if we check that again, and we'll stack that, they should line up exactly. And again, if you did like the test with join, just to see how they smooth, you can see it smooths pretty nicely. That's looking pretty cool already. And feel free to take some liberties, you know, make things look weird and model them. Thanks, Pack. I'm glad you're liking it. And the next thing, I'll bring this over. The important thing is to just have fun. You know, when I was making these shapes, there was just like as the test for this file, I was doing so many different types of mistakes and like edits and changes just to see like what I liked, what I didn't like. Sometimes it's ugly, sometimes it's nice. I mean, it just really depends. So what I'm going to do here is I want to make a hole from here to here. But if I just do a bridge, it's going to get weird because the geometries are just like, it's just weird there. So what I did was I inset, remember our inset tool from the first thing we did? I just did inset. And did something like 2 maybe, or maybe 1. So I just inset it. So you get like that kind of topology there. And then I'll inset also this face. Inset. And then I'll bridge like these middle faces together. And you sometimes get weird stuff like that you have to fix. See how there's like kind of like intersection because of just the way that the geometry is. So you know, you just pull things around. Like I think if you pull this edge up, it'll fix it. Yeah, see. Just pull the edge up so that they're not, you know, it's not intersecting. You can even like scale these in a bit just so it's cool. So we have that. So now I will copy this out. So the next part that we're going to look at is this, like what I call in this case the detail, which is like this kind of like little extra decoration, which I think it always kind of looks nice. I actually want to make this a bit thicker. All right, so step 1 for making it like this kind of purple geometry that like follows so nicely everything is not following so nicely there, but that's okay. Oh yeah, I know what that is. Okay, so I'm going to go into my detail A, unit 1 detail A, just so I can keep track of what's what, and we're going to do what's called an offset sub D. And it's select the whole sub D, enter, and then it says the direction and distance. We can see what 1 gives us. I think that's fine. So now you have this outer shell sub D. You can see our original one inside of it. And that's going to be our starting point for the detail sub D. So we just go here, and we just go to detail A, just to put it on a different layer. And then I just hide the inner one. And I just start deleting faces so that I'm left with like the faces I want to keep. How to select the edges in a loop, shift, control, double click. So you just start deleting faces that you want to keep, that you don't want to keep. And in this case, like it's a bit experimental. In this case, I ended up with this, so I'm just going to follow that for now. So just select faces, and as you're going, you can delete them. You can see things will start to look a little bit weird as you're deleting faces. Something like, I got rid of this too. So get rid of this. Then I have this like one coming into here. Those. This is just a way so that because you're starting with the base geometry and then offsetting from it, like you get like a nice thing that like follows along with it. So it is. Deletes this. 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 And I want to get rid of like some of these bottom faces too. Just get rid of a bunch of them. Oh, I kept that hole there. So we have these faces outside the hole. What else do I have to do? That. Okay, so you should be left with something like that. Oh, get rid of this one too. In my case, if you do different faces, that's fine too. Like offset and sharp edges rather than curved surfaces. You can offset solid, sharp edges and curved. So some of these are curved by nature. So yeah, I mean, yeah, I don't know why. Like, yeah. So the tab concept, just press tab. There's no difference between them. They're just different ways of viewing the same geometry. Okay? That's really important to know. Okay, sure. So now you have this. So the next step, yeah, you can crease. I avoid creases though because they're pretty terrible in Grasshopper, so they usually just get destroyed anyway. If I'm going to if I need something like crease up, I like usually do like the old school Maya way, which is to like just double up the edges rather than use actual like crease. But you know, I think if you find a way to use it. Okay, so now you have this. The next step is to like fix it up a bit because you can see like there's intersections and some weird stuff. So what I do is I just go through and anytime I see something like that, I'll like try to clean that up. Actually, just need to lift this up. Yeah. So you see how it like kind of cleans. Now there's not that like, weird intersection there. You also have some stuff here that's a little bit weird. So you can move this over. So we want to clear those pieces. You can like thin this. You can do scale 1D, then like select here, and like bring that in like that. Same for here. Scale 1D. Something like that. How do we make sure there's no intersections with your eyes and orbiting? I guess you could run like an intersection test. I don't know if intersect if it works for nerves. We could try it. Intersect. Does it work for it? I don't think it works for somebody. Let's see. Oh, yeah, it works. You can use the intersect command if you want to see like where they collide. But for the most part, it's pretty easy to just see it, I think. But yeah, if you want to get like technical, you could definitely use intersect just to visualize where they're in fact intersecting. I want to move this. Up more. All right, cool. We're in good shape there, I think. That's a detail surface. We offsetted this surface, offset sub D, to get a second sub D, and then we deleted a bunch of faces from it to get that second surface. Sub D and Maya matches. They both have their advantages and disadvantages. Sub D is true curvature. Maya is polygonal modeling, so that's one thing to consider. I think Maya has a lot more. It's a lot easier to model Maya right now, but it really depends what you want to do. Like in Maya, you'll get a preview of the curvature, but it won't really be the curvature. Whereas this is more nerves like. Okay, so let's move to the next step, which is thickening up this detail. So we thickened up that detail. We'll go select it. And what we're going to do now is the same. We're going to do offset. But we're going to change solid to yes and delete input to yes. And we can change the thickness. In my case, maybe 2. So let's go back to 1. Here's an annoying thing. You see it offset solid. For some reason, offset solid doesn't have an option to crease or uncrease, so it automatically creases. So you see how it's like got like a hard edge because it's creased. What a crease is in sub D is there's crease and uncrease. So for instance, like this one, if I wanted like a hard edge here, a real hard edge in smooth mode, you just press this button, add crease, and it would like crease it, you see? It's marked by like a black line, darker line. But here we want this to be smooth. So what we're going to do is we're just going to double click the entire edge loops. Like that. And don't forget this guy in here. So you have those like hard edges selected, and then just select this remove crease. so that we're like back to a smooth geometry. And then again, like you can see here, like you can get, the more you play with it, like I don't want to spend too much time just like while I'm listening around, but especially because I've given you things, I just want to show like the kind of process. So you can, you know, just play with these, sculpt it to your liking. I'm just going to stick with that for now. Maybe it's fine. Let's go down, actually. Okay. That's fine for now. So I save that. So the next thing is just like we did when we were making these little guys over here, is like then we take it and we deform it so that we don't change its topology anymore, and then we can morph between them. So and you know, again, so the important thing is you don't want to use tools like subdivide or insert edge or delete edge, none of that. Like you need to keep the same topology. So all we're doing now is just manipulating the topology and the mesh to, you know, deform it into something like that. We're not adding or deleting stuff. So you can, this part you can have a bit of fun with, and don't, oh, and this, in this case, for this first one, make sure you don't change this openings, right? Because that, remember, with the tween method, we need those openings to be the same. So you can, I don't know, maybe like drag this out, scale it up big. You can get like crazy with this thing here. Now I was like dragging it like super far out, like really bubbly. It seems like my edges down here didn't uncrease, so we uncrease those. There we go. So I'm pretty sure I selected them. So in this part, just like have fun. Like as long as you don't intersect. I would say the 3 rules would be like, try not to create intersections, don't change the openings, and it's usually best, but you could sometimes get away with it, to not exceed the heights of the openings. Because there is potential, if you had something over here, like when you stack them, this could intersect it. In this case, I don't think it would matter, because if I went like that high and stacked it, like you see, it wouldn't hit something else. But if like this was also like down, let's say like just for the sake of argument, if this was like that, like when you stack them, you could get like a, so you just got to be mindful of that. So I always do like this kind of test where I stack it on top of each other just to see if there is any issue like that. So good to like just double check stuff. So now really just have fun like deforming this thing. You also want to make sure, like, I mean, it doesn't matter. Like if you intersect, it's not the end of the world. But it looks cleaner when you don't. Like the geometry just looks nicer in your renderings and stuff. So I like to just make sure things aren't intersecting. I don't like this, but it's like more bubble looking. Anyway, I don't want to spend like waste too much time on like that part, because that part is really like up to you. You just have fun with it, really. And I already have it here, so I'll use those. I just wanted to show you how to get to like this point. So you deform it, which is what I have here. And then the second deformation that you can do for the other method is you take this, wherever your stopping point is, you copy it over, and then that's the point where you can actually like change the openings to. So you can do one where your openings are massive, like that. But you just gotta make sure that whatever you do there, you do here. So they should be the same top and bottom per unit, but they don't need to be the same across units in this case. So just, and then you would have to do the same thing where you would just like take these. Now you'll see something interesting here. You see how it intersects in box mode. That will happen because, especially when you're doing like these extreme curvatures, it's okay. We want to make sure it's not intersecting in the mode we're going to use, which is like the smooth mode. However, in some like cases like this, you could like just nudge over it. So at least the edges don't just preference. So don't worry too much about intersections in box mode when you're working with like extreme curvature models. And then we'll do this again. We'll just like project these both. Project to C plane. Yes. And then they should be there, right? And then we move them to the height. Move vertical. So now they're at the right heights. And then we just edit these so that they match. So turn the points on. Get some crazy stuff there. So that's like that, and then you just look for stuff like that. Like if something like that happens, just fix it real quick. In this case, I could just move this bottom face out. And like make this really fat. That's cool. And I also like to, what I also like to do, which I did here a bit, is like you can also like separate from the geometry. I think it looks kind of nice sometimes. I think I did that more like in this one. I was creating like these openings. It's creating like these, where it kind of flies away from it a bit. Those kind of like little details look nice sometimes too. In that case, you can just like grab something like this and like actually just pull it away. And then you can fatten this up, shift select, and then scale. Maybe something like that. Maybe too far, but anyway, really have fun with it. And then after sculpting, you can get, playing with it, moving around, you can get something that looks like really, refined and polished and nice and curvy in this case, like this one here, which I think is quite nice. when things are at different heights. So you just got to play with it. But the point is like you model this thing. So just an overview. You model this base, and the base needs openings on top and bottom that align and are the same size. They align when they're stacked and they're in plane with each other. You then offset that and delete faces to create like this kind of secondary detail surface. Then you fix that detail surface so it's not intersecting. You thicken it with offset and remove increases. And then you copy it over and do one manipulation where the holes don't change and another manipulation where the holes do change. So this is for our tween method, and this is for our blend method. And they'll be tweening to this one or blending to this one. Okay. So why don't we take another 5 minutes? This time just a 5-minute break, and why don't you just play with that? Try moving things around. Let me save this. So try pulling things around, pushing them around, and see what you get from it. See what kind of things, and just get a bit familiar with pulling things around. Are polysurfaces you get from sub-D to nerves, curvature, continuous? Yes, I believe sub-Ds are using a Catmull-Clark algorithm, if I'm not mistaken. They are curvature continuous, yes. Okay, so I will see you in 5. Hey, I'm back. Will you have access to the recording if you leave? No, you'll never have access. I'm kidding. Yeah, of course you'll have access to the recording. Don't worry about it, guys. You'll all get the recording. It's okay. Um, you'll get it. Uh, so yeah, if you have to leave, it's fine. You can watch it later. It might. There's a lot of people, so it might take a day or two. But yeah, make sure um, to check your spams as well and stuff. So okay. Go back to business here. Okay. Um, so next thing I want to do is I want to hop back into Grasshopper and build out. Can you use mesh negative like the openings? Yeah, you can. You can. You can any way you want to get them. It's fine. You're welcome. Okay, so next thing I want to do is I want to hop into Grasshopper and build out the Grasshopper parts. Now that we saw how to build one of these, and you have the file with the two kind of already manipulated, or you can use your own that you're manipulating. And then I just want to see where we end up before going so much into these. The process is similar, and I'll go over it either way. But I just want to make sure we definitely spend time on the Grasshopper parts. I think it's more important because the units can be anything as long as you follow those principles. So let me get Grasshopper up. Okay. So the first part is we're going to make some twisted boxes, and there's many ways to do this. I'm just going to do one way, and then I'll do another way, and there's many other ways also with the tools. But let's just start simply. So I'm going to go into since we're working on unit 1, which is this unit here. We're just going to go into the guides and host. I always call things hosts that are like the thing we're putting things onto or into. So if it were like putting on the surface, I'll call that the host. Or it's just the way I name my files because they're like hosting the units. So, in this case, we're just going to use some curves, and I'm just going to start with a circle. And I'll just build it out like over here. It's fine. Something like that. Just make a circle. And then I just want to rebuild it so it's a nerves and not like a circle, because like when it's a circle, you get these sharp points when you manipulate. So we just type rebuild. Rebuild curve. Never understood why that one is two separate. It should just be I guess I clicked something else on accident. So rebuild, I don't know, point count 10, degree, make the degree 3. You want a degree 3 curve. We can delete the input. Okay, and you'll see like the points are now like closer to that circle, and like there's no more of that like sharp pinch when we move things around. In this case, I'm going to use. I'm just going to use 3 of them. So I'm just going to hold Alt and drag up, hold Alt and drag up. So we'll just start with that. And the component we're going to look at right now is called Twisted Box Pipe, also part of Pufferfish. So Twisted Pipe. This one here, Twisted Box Pipe. and these are curves, which it's calling as sections. Oh, sorry. It needs a surface, so we're going to make that surface simply by lofting. We're just going to loft those curves. Set them in, set multiple curves. 1, 2, 3, and 2. So now you have your loft, which is essentially a pipe. What this twisted box pipe component does is it just makes twisted boxes inside. See, makes them inside of that pipe or that surface. So like if I did something like this, right, it's going to do something like that. So that's the idea. That you have those boxes there, and we're just going to mess with it. We're not going to mess with. Well, we could mess with these. That just changes. I'll show you what that changes. Let me just first do the U section. So we do, as we do with everything in Pufferfish, because it's using parameters, we get our usual setup, which is a range and a number of values, and start smaller like that. And we get our graph mapper for extra fun. Good to hear that, Xavier. Definitely get into it. It's a lot of fun. All these kind of tools are really fun. Grasshopper, Houdini. I'm working a lot in Houdini these days. So you get the graph mapper and you. So you can see how you can change that, but you can also change like that as well. And then with we don't need to mess with the V1, V2, the V4, but basically what that does is it lets you change their single value parameters. It lets you just change like where those corners are on the pipe. So again, like if I just do something like this, right? But we don't need to really mess with those right now. I mean, you can if you want, but you don't need to. So feel free to, I can actually, there's default to 0, 0.25. So all like their basic quartered 0.25. Just leave it here in case you want to. Weighted is just like the weighted we saw before. It like puts, sorry, this should be 0.75. Something up there. The 0.5, 0.75, because 1 and 0 are the same. We have 0 already. Okay. So those are those. You can change them if you want. Weighted just means like if there's curvature, it'll change the distribution. And then flip is just because sometimes if your surface is flipped, this will be wrong because it won't follow the direction that we need. So if I flip this, you see how it gets all like weird. That's just like if this surface was, I changed the UV directions of this surface. Like it really depends how you build the surface. So if that was like going the opposite direction that we need, we would just, this toggle just corrects it. So if it looks weird, you can always correct it with that toggle. Yeah, I can share the Dropbox. There you go. All right, so we have our kind of twisted box network, our basic network there. By the way, with twisted box pipe, like I was mentioning, definitely check out the example files because there's so many different ways to make these, but there's also a variable version, which will let you do a different different values, so you can actually like make this thing like crooked. Um, so like if I did something like that, and then did something like that, so instead of controlling like it does here, let's see, it controls all the U direction. Here, it's going to control each corner. You can control each corner of the direction. So if I did it for this one and I only plugged it into that first corner, you'll see like that first corner like drop. So this is like by corner, and this is like by all the corners. So there is that variable, but we don't need it right now. But just know that it's there if you wanted to give some extra information. Why called twisted box? It's just what Grasshopper calls it. It's a native Grasshopper type, but there's just not many components for it. So if you go to like where is it? Transform, morph, you'll see that there's like first of all there's surface morph, there's box morph. I don't even remember where the twisted box stuff is. There's only a few of them, but oh, yeah. So this is the Grasshopper one. So, yeah. By the way, if you want to know where a component is, you can just hold Control and Alt, and you'll get this little like eye. See that little like eye near my cursor, and you just select it, and it like puts these arrows and shows you where it is on the tabs. And so like that's Grasshopper's native one, twisted box, box morph, blend box, surface box. But that's all that there is, and I just thought it's a really nice concept, so I just took it like to the next level and made all these components for it. So it just was really like underused, I thought, or under like kind of overseen. So yeah. And I guess it's called a twisted box because it's a box that could be twisted. Like the corners don't need to align. I don't know. I have to ask David Rutten, who developed Grasshopper, why he named it that. But it is what it is. Twisted box. Again, like I'm just getting this parameter. Like I explained before, like I just like to use them for just for clarity and ease of connection. So now we have some twisted boxes. So, let's first build out the method that lets you do tweening. Okay. So we need our inputs, and we can input them all together, but I want to be a bit more organized. So we'll get our sub D and control polygon kind of set up here. And I'm going to just keep this here, and I'm going to work on this like kind of off to the side over here, so I can use this for like either of the two methods we're going to build. So we need 4 of them because we have 2 bases and we have 2 details. So we need base and detail, base and detail. And to make that clear, I'm just going to say like base A. It's a little hard to see because of the things, but actually, let's just do it. Let's just get a scribble, base A. Base. Oh, sorry, detail B. Sorry, messing this whole thing up here. Detail A. A's go with A's. Base B. With and I'll just like group those together so that we understand what goes where. Okay. So we're going to plug those in, and that's going to be from here. Now I want to mention in the file, once I'll explain it more once we get this file done, but why are these sideways and rotated? Because also the orientation of them in 3D space determines how they will morph into the boxes. So if I took this and turned it this way, it's going to morph in a different relationship into the boxes. So the example I did for the poster image, I oriented them this way. So it'll make more sense once we get this built out, but that's why they're like sideways, I guess. So let's just turn these on. And we know we need base A, and base A is here, or it's basically your inner one, the smaller one before you deformed it, this one here. So set one, sub D. Just check that it's there. It's there. And then detail is that one's detail, right? So it's the smaller detail. And then we need base B and detail B. So base B is going to be our really deformed one there. And detail B, that one, right? So now you have all your things set in there. So what we want to do right off the bat is we're going to match the bases with the bases and the details with the details. So we're going to get entwine. And we're going to make two lists. One list of bases, one list of details. So we'll take base A and then shift and drag base B into the same input. And then do the same for the details into the next input. So what that did, if we look at our param viewer here, is now you basically have two lists, and each list has two items. You have your bases and you have your details. Again, lists are the hardest part about Grasshopper. It's the hardest hurdle, and you'll really only learn it from not a 5-hour webinar, not any 5-hour webinar, but from like doing what webinars like the Mode Lab one, Intro to Grasshopper, and going over it a lot, and then just having like going through like experience and learning. I mean, no one's really the people that are good at this stuff. Like me, are just because we use it all the time. Otherwise, I would not be good either. I'm just using it for years, every day. It just takes time. So don't get frustrated if you don't understand it right away. The more time you put into it, the more you'll get out of it. So we can get, someone mentioned before, can we use just get naked edges, whatever. In Pufferfish, I have the mesh naked edges. Edges here, and you can just use that, and we're just going to flatten it so they're all in one list. So we'll actually we don't need that. We can flatten it here, because if you do that, it's still going to output like how many openings per mesh. And so if we look at this, it's basically telling us that it's telling you that each detail, base 1 has 4 openings, base B has 4 openings, the details have no openings, as we know. But it's okay, we don't need to worry. Like, it's useless to try to filter them out, because we're just gonna flatten this anyway and have one list of the 8 openings. So it's okay. It'll make you ignore it, and I don't need to reverse that. I don't know why I did that. So now you have those edges, and you can see them here when I select this. The only reason it's yellow is it's just telling you that a mesh has no naked edges. That's because the details don't have any naked edges. So it's okay. We can ignore it. It's fine. So we'll do our bounding box. And remember, make sure to set it to a union box. So that now you just have one box that's only bounding those things. But if you remember now, the relationship to the geometry to those bounded boxes is humongous. So when we put it in there, everything's going to be huge outside those boxes. But we always want to make sure we capture those. So what I do is I capture those, and then I'll do something like scale it, scale NU, which is like the scale non-uniform, to make sure I don't scale in the direction of the openings, and I only scale in the other directions. So get scale NU. And we'll need the center of the box, so get volume. Center. And the geometry we want to scale is the bounding box. And we only want to scale it in the Z and X direction in this case. If we rotate it, we're going to have to change that as well. We don't want to change it in the Y direction, because we want our connections to hit the top of the box so that they connect when stacked. So I'm just going to get some sliders. Let's say something like that. I don't imagine us going more than that. Or actually, we might. So let me just go 5. Okay, I'm going to set them all to 1 by default. 1 is no scale, right? It's scale factor of 1. 1 times anything is the thing you times it by. So nothing happened. And what we want to do is, again, we want to scale in X, so we can do like something like that. It doesn't need to exactly hit, like it can be whatever, like, and these you'll play with too to like change the design a bit too. So let me like this stuff so you can see what's going on. And we can change the Z also. That's fine. Capture this out a lot more. So yeah, something like that's fine. But the important thing is that we don't change this one. We don't want to like come off of those openings. So we just keep that on. Okay, save. All right. So next is to the next thing is to blend those units. So we got to get the factors for them. So we get that box centers. Remember, always flatten the output so that we have just flat list of centers. And what I like to do is I like to put one of these in like the front of this, just so it's easy to, like when we do different types of twisted block stuff, we can like replace easily. So we'll use this to feed into our definition. If I needed to remove it and put it somewhere else to like another definition, I can do that easily. And then this is going to be our twisted boxes. So now we have the center of all the twisted boxes. And to make this neater, if you just double click on the wire, it'll give you like a what's called a relay. It basically just makes the wires easy to move, like shape. So you can, like, instead of it going through that, you can just kind of something like that, just so it's a little bit nicer, a bit cleaner to read. Something like that. Okay, so now we're going to make the attractor. So I'm going to go into my unit 1 attractor file layer. So just put it there somewhere. We can change it afterwards. Point. That's 1 point. So now you have your attractor. And again, it can be multiple attractors. So I'm just using one for now, just like we did before. And then just do pull point. We're going to pull 2 points with the attractor geometry. And the stuff should start looking a bit familiar to you. Like, so then we're going to reparameterize the numbers. Boolean toggle. As always, graph mappers for fun. And I'll use the usual fuzzy. And so now, like we did in our small example, like way over here, when we did the tween one, we're measuring from this point to all those points. We're going to use those to tween the units and determine where they go. So we'll get our tween through meshes. One thing I want to note before we go any further that I kind of glossed over, interesting to note, if you don't know already, subds and meshes can be joined even if they don't touch. So like, for instance, see, we have this, like, these two objects aren't actually together, but they can be read as one if you just type join. That's why, even though there's like 2 pieces, I only had to set one detail because it's like read as one object. If you typed explode, you would get them as like separate, or in mesh, you can do like disjoint mesh or so. Just keep that in mind, that they're one object, even though they're multiple parts, because we modeled them that way. So we're going to take these from here, our 2 things here. So remember, we have 2 and 2. So since they're in their own list, what it's going to do is it's going to do the tween operation from base to base, because there's 2 bases, and then from detail to detail, because there's 2 details. And since we have them in that list together, this tweens per list, the tween through meshes. So it's going to tween only in the first list and then tween only in the second list, so they don't get mixed up with each other. And then the factors. So we're going to use those factors for every list. So the factors are only one list, but they're going to be used for both of those lists. That's how the list matching works. If you have one, list like this, and then 2 lists like that, basically what Grasshopper is going to say is, okay, take all this and do it here, and also take all that and do it here. And it's just going to do that until it runs out of lists. That's how the matching works. All right, so let's now morph. So we'll go twisted box, and we're going to morph these. We're going to morph these with our reference box. Just, okay. Okay, so we're morphing it to there, and we're going to put it to our twisted boxes, which were from here. And you can also do another relay if you want to clean that up a bit. It can be like something like that. So now if we look, we have them all here. But they're as, you know, they're as their, because we're using the mesh, they're as their unmeshed, sorry, unsmoothed versions. And, well, obviously we need our factors. So we forgot to plug our factors in. I was wondering why does it all look the same? Put your factors in. There you go. There you go. So there's our first tower. Pre-smoothing and joining and whatnot, all that fun stuff. So if I just bake this out real quick, just so we can look at it. I keep baking things on red layers. It's really hard to see like when they're on red. So I have like result V1 base. I'm just gonna put it there for now. We know we're gonna delete it. And just select it all. Just want to show you what it looks like. Right, so there's our thing there. If your thing, if it looks like weird, also twisted boxes are very sensitive to like the position in terms of like if they morph them correctly in terms of like if they're flipped or not. So you can see like, if I go to actually Arctic, you can see it. Oh no, Arctic hides it. But you can see how like you can kind of like see through it a bit. That's just because it's like the normals are backwards. And there's no way really around that. It's just something you gotta see afterwards. Because again, like if I turn this another way and it morphs, it could be correct. It's just the way that morphing works in Rhino. It can be a little weird sometimes. So just something to note. And actually, we're gonna go to display, and it's like color back faces and make it red so that it's obvious. And so you can see that everything here is backwards, right? And that's because there's two things you can do. You can either, after result, flip everything. So just like it, flip, and everything's now the right way. Don't mind these intersections, because again, they go away once we smooth them. The other thing you can do is flip the curves, because again, what's happening is, depending on the orientations of things, sometimes the normals get reversed based on like the Rhino's deformed space. And there's really nothing you can do about it except for just knowing that it exists and knowing what to do to fix it. So if I flip, you can actually see that the color changed. And the geometry changed a bit too, because now it's like facing the other direction. So actually, if I look this way, it would be the same. So now if I bake that also, so it also depends like how you draw your guides, but now these are correct too. So either one works as you please. Either flip the curves or flip the mesh afterwards when we're done. Then, so how's everyone up to that point? Yeah, we'll unify the normals after. The thing is, if they're all backwards, it's just going to unify them backwards. Does that make sense? When you unify a mesh, basically it takes the direction of like whatever direction most of the mesh faces are, that's the direction it unifies to. So if they're all wrong, if they're all inverted, then they're all going to unify to be inverted. That makes sense. That's why I didn't use unify to fix that specific problem. Unify is good if like one or two, or like if a few mesh faces are for some reason the wrong way. or like one unit's the wrong way and the rest aren't, then it works good. Explain the process of tweening through meshes to more. Yeah. I mean, we explained it a few times, and that's basically what we did up here and up here. But basically, and I know it's because you have to understand like a bit of lists. But if I get a line here, go from here to here, right? So basically, what you're saying is, you have this unit. You have this like, you have this A, and you have this B, and you want to, like, let's say you have A and B, and you wanted to make, it's gonna look weird, but C. Yeah. So let's say you wanted the middle of that, right? Let's say C is somehow the middle, right? So you say you wanted that 0.5. Like say you had only one box. Well, maybe we can actually visualize it easier that way too. Let me reduce this height. Okay. So say you had let's say you had 3. Just draw this. And let's say you have and you want like 1, 2, 3 blends, okay? But how much to blend? Basically what you're saying is, here's 1, here's 2, here's 3, and you're taking a distance and then making it to 0 to 1. So what you're saying is basically, okay, the unit that's going to be in this box is going to be blended, to points that would be like 0.25, let's say, right? When it goes to 1. And then this unit, because it's further away where we're at, is 0.5, and this one's 0.75, right? So all in one, what you're doing is you're basically have these positions. I'm just going to draw this stack this way, right? And you have this attractor. And you found the distance, and let's say this distance became 0.25. This distance became 0.5, and this became 0.75. Sorry for the crappy handwriting there. So what's happening is now you're giving that value to the tween that would be in that box. So now tween 1 equals 0.25, tween 2 is a tween of 0.5, and unit 3, the third one, is a tween of 0.75. So it's tweening that amount from A to B and then putting it in its respective box. I hope that makes sense. Yeah, if your meshes are having issue, that means you modeled incorrectly. So when something doesn't have the same topology, it means if you had a box, right? And the box has 1, 2, in this view, just has those vertices. Now you can't, if you wanted to blend that to another box for some reason, if you wanted to blend that to another box, it needs to have the same topology. What that means is that this point and this point are in the same order. Like, it's blending those points. It's basically blending the topology together. Now, what your error means is that you have one of these objects is a different topology than another. So for instance, let's say I subdivided this face. Well, now I have more points here than I do here, so it doesn't know what to do because there's nothing here to blend to here. And then also the order of these are going to be different too. So you know this might like go like somewhere over here or something. So it's like that all that means is that you have more information on one shape than the other shape, either more points or more faces. So that's what that means. So if you're having that problem, just use, for now, you can use the ones I modeled, and then you can go back and just make sure once you get to this point and you're making those two that you deform, that you're only deforming. You're not adding or deleting anything. No edges, no faces, no points. You're just moving things around. If you're having that issue, that means you've referenced the incorrect things because you've seen that I've literally just done it. So if you're having that issue, it means something's wrong with your Grasshopper definition, or you've clicked and set the wrong thing. So just check through, make sure that you've set the right stuff. Make sure make sure you input the right stuff. You can download this file if you want. I'll save it right now. But it just means that you've done, overlooked something. Flip curves won't affect the points because they're just making boxes you're morphing into. It's just changing the direction. Yes, one tween per one box. That's exactly what you're doing. Measuring the distance to the box to make the amount of tween in that box. Like how much to tween the one in that box. Seems like a surprise at the end. Well, surprises are fun. I mean, you just play with it, really. I mean, that's the fun with it is like, that's the fun with all things computational. It's like that you don't really always anticipate it because it just can do things a lot more complex and a lot faster than we can do manually. But you get an idea when you look at like the kind of thing you're making, and you can like I was doing, like you can like stack them just to see like what's going on as you're going, just to see how things look. It's a back and forth. If you're asking which model I reference, I mean, you could just download this file. I mean, that's what's there. I'll put it here. Yeah, you can just check through it, but it's like it's this one here. So you have base A and then detail A. So the base A and its detail, and then you have base B and detail B. So those two there. That's all. And they're also on layers too. Unit 1, base A, base B, detail A, detail B. Exactly, yes. The details have the same kind of list as the base, so that's why they match up. Yeah. Then move base A and B apart and just tween through meshes instead of having to morph just with the boxes. Have the same outcome. I think it will be difficult to align top and bottom. I mean, if you just wanted to stack, you can do that if you just calculate the height, but we want to do things like make like some cool shapes and stuff. So you could, if you were just doing a straight line, you could just you could just even just tween it and move it if you wanted. But that's not the point of this. We want to deform. Why is my model getting rotated when I'm more? Yeah, so I explained that. It's all about the orientation here. There's a few things that factor, and they're just things that you'll become comfortable with as you do it. Direction of curves, order of curves, and orientation of the units. All these things, when changed, can create a different orientation of the morph. So they're all things you have to be mindful of. It's not like just because you do this and then in this, it's going to morph the same way. It's not, because the bounding box, the reference of the bounding box is different. Because the bounding box, if you did here, the bounding box would be the top, but now if you put the bounding box here, this is going to be the top. The edge is going to be the top of the bounding box. So it's just going to go in there differently. And then depending on how these are, this, if you rotated this, or, maybe this is the top here, but if I do this, now like that's the top, so it's just a bunch of things. You just got to play with orientations. All right, let's get on with this. Okay, so we're morphed. And that's why I wanted to explain. Oh, that looks weird because there's so little of them. Just do something simpler like that. And let me just hide this. So like, if I rotate this like that, you'll see that whole thing like rotated, right? So if I put this way, or this way, so it's all about orientation, just things to be mindful of. And then if I put this way, it's not gonna work, because now the opening parts that we want are rotated the wrong way, and our bounding box is incorrect now because of the way we scaled it. Now our bounding box is like that, so just everything just looks crazy because it's going like in this direction and super huge bounding box. So just stuff that like there's it's just understanding how things morph in Rhino, like behind the scenes, really. Okay, so let's move on to the next part, which is going to be about closing this thing up and mirroring it and all that fun stuff. So next we have to do is join. And we want to join, don't flag it first, because you want to join the details with the details, and you want to join the bases with the bases. So when I bake, if I bake this as an example now, if I, so I'm running a command. So bake this now, like all the bases, since they were connected and joined, are all like one object, selectable object. That was the details, and then there's the bases. And then we'll flatten that after. And it's just a flat list of two meshes, a detail mesh and a base mesh, as you can see there. Why are the range values one of those? Because you're going for range. What is range? Do I have range here? I don't. Because you're going from like it's intervals. It's just here. Number. So it's the number of steps, not the number of values, right? So if you took if you took 10 steps, you'd actually have done 11 foot placements because of your first kind of foot placement, if that makes sense. So like if you divide a curve, by 0, so it'd be like divisions 10, we go here, you're actually going to have like, there's a difference. Actually, this is a bit different, but the idea is the same. It's like if I had, just for this one here. So if I have here 11, if I had here 10 steps, so imagine that steps are the lines, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 steps, the line segments, but there's 11 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's what a range is doing. The step, which is asking for, is basically like the gap between the numbers, and it's outputting you the range of numbers, which is like the steps. Hope that clears it up. Okay, back to what we're doing. Mesh join. So now we have this joined mesh. And what we're going to do is we're going to rebuild. So we need to do some cleanup. And we have a nice component in Pufferfish called rebuild mesh. So plug that in. And we're going to get a Boolean toggle. And so we want to rebuild the normals. So that just usually sometimes when you're doing morphing in Rhino, the normals get messed up, meaning normals like this, not the direction normals, but actually like the display normals. So you can kind of see it slightly, it's like has to do with the shading. You can see it slightly change colors. I don't know how good you can see on zoom, but you can kind of see the sheen change. So that's like just fixing the normals so that the shading is properly displayed. And then the cull unused is basically just going to remove any vertices or faces from the mesh that are like extra, not being used. Sometimes you can get overlap points and extra points. You can have points that don't have faces attached to them behind the scenes. That just clears all that stuff in the back of the mesh data if there is any. We're going to unify the normals. That just makes sure that everything, all the mesh faces are in the same normal facing direction. Flip, we don't need, but that would flip the mesh. You could have also used that instead of like reversing the curves like I did. And then this is an important one, is identical combining. So we're going to do that. So what that did is, if we look at our meshes here, notice how this one went from 880 to 808. So what that's doing is saying, like, if you have two mesh faces and there's a vertex in each one, but this point here actually has a vertex from this face and this face. So there's actually two vertices there. All that does is it deletes one and makes it one. So now they share vertices rather than having their own vertices that overlap. And that's why you get that reduced number. And then to take that even further, we're going to put 0.01, some small tolerance. We're going to do welding. What welding does is if there's any points, and in this case there isn't, but if there is any points, because when you're doing all this kind of like morphing, this and that, a lot of times like points get out of whack and slightly off from each other. So this one captures it if they're not exactly on. So if there was like basically if there was a mesh like this, and then another mesh that was like, if I zoomed in, it was like slightly off, and if that tolerance was within that number, it's just going to snap those two together so that this comes like they'd snap together, and then there's no more like gap. That's basically what that's doing. Okay. So that's what that does. All important stuff. Here we got rid of almost 80 vertices, so that's good. 80 duplicate vertices. That's important for when we like smooth stuff together. Okay, so the next one is we're going to use a mirror just to give some, some fun stuff to that. Well, actually, I'll show the smoothing first, and then we'll mirror. So once you have something like this, what you want to do is you'll notice when at the top and the bottom, there's still like these openings. Oh no, it didn't. It's just because this is on. To have these openings, we want to close those up. So what you're going to do is just going to get in Pufferfish, we have a nice closed mesh. Just close it up. That will fill all those holes. So now you'll see that that's closed up. So we'll just find those and close them. It's yellow again because some meshes like the details don't have any openings. So it's just telling you that like there's some meshes that don't have openings. It's fine. And then we're going to like smooth this thing. And this is where Weaverbird comes in, which is here, WB, and the sub D, which isn't really sub D. I mean, it's called sub D for subdivision, but it's not sub D like the sub D object. A little confusing, but Weaverbird's a lot older than the sub Ds in Rhino. So to be fair, when it was named, there wasn't sub Ds in Rhino. So I'm going to get this Catmull Clark, which is actually the type of smoothing that Maya uses and that the sub Ds are using as surfaces, but this is it as mesh, right? So we're going to get that mesh, that closed mesh, plug that in. And you can see it's already gotten smoother. And we're going to have levels. I suggest not to go over, even the component really won't let you go over 3 because it's going to make a lot of faces. So I usually stick around 2 or 3. That's the levels. So you can see how that got all nice and smoothed up. And our connections are nice right there. Like that's a detail. The details don't connect, which is I like. But the bases connect. And then we can just split that out into parts for baking. So we can do a shift paths. So if you look here now, this part might be confusing if you don't understand lists. You basically have, oh, because I didn't do the mirror yet. That's right. We'll do that after the mirror. Okay, so if I bake that, you got some nice thing like this. That's all nice and joined together and blended. You go to Arctic. So it's looking pretty sweet. Right, everything's connected. When you zoom in, like you'll see the triangulation. That's just the render mesh in Rhino. You could change that setting in Rhino. Again, that's not the geometry. That's just the render mesh, the way Rhino's displaying it. I don't suggest changing it though in Rhino because it can make things so slow. So I just keep it like that. So that's looking pretty sweet, I say. And you can see like down here, we have that one that's like a bit less extreme. And then up here, it's like the way more way more extreme version. That was actually I only grabbed the both. And go to Arden. Oh, there we go. Now you can see what's there. So you can see how that tween is happening, right? Like you had like the bigger opening here, you have like the fatter opening up there. Really fun stuff. And of course you can move the attractor. So if you move this around, that changes, or if you move it up, it'll like be opposite. Or you can even just like do our invert the reparameterization. That will also make it opposite because you're inverting the distances, the distance values assigned. You can play with this kind of stuff here. This is gonna change like how it, change. It's giving a fall off to the blend. So it's like here, it's like almost all like the first unit, and then it starts to blend. So all stuff to play with there. And then, of course, if you change this too, that also changes proportionally, like we know. It's easier if I turn off the mesh edges. So if I change the bounding box here in the corner, let's see, like when it's bigger, that gets smaller. When it's smaller, that gets bigger. Same in this direction as well. But the one thing we don't want to change in this case is this one, because if I do that, you see how they don't connect anymore. There's actually a moment where you can see it like grab, and that's when it's like at 1. So that's why you don't want to mess with that direction. Maybe we'll set that to 1. Cool. So now we have this, you can have like some fun with these. So you can shape it. You don't need just 3. You can have more too. You can add more in there. You would just set them back in here where we made the twisted box pipe into this curves. So now you can just shape it. You can even like do stuff like that. Have fun a bit with like just changing things. Maybe we want this bottom to be like really small. This one to be like humongous. You even give it a little bit of a twist and like rotate this top one, let's say like that. Rotate this one a bit. So it's very like, it's like, parametric and manual process, which I really like a lot, that kind of mix. And then even more, like if you actually went here and changed the unit, it will update there too. Like, so if I went here and just like, if I just like grabbed this and just like dragged it like, I don't know, some crazy place like that, you'll see nothing happen. Oh yeah, it did happen. Okay, yeah, it did. I see. It's on the other side. It's going down actually because of the way we put this. So that will all update in real time too. So that's where the fun begins. You're going like back and forth between like manipulating the modules, manipulating these drivers, changing things like the bounding box and the attractor point. It's a lot of fun. So save this. You lost connection. Well, I mean, it's okay. You're back now. And another thing you can do, which let's see if it, you can do like constant quads. You can give it like another level of subdivision. So constant quads will subdivide faces without smoothing them. And then if you did like that into Catmull Clark, what's going to happen now is you're going to get like more of like a hard edge look. So if I bake that and just go Arctic. So now things are a bit more like hard edge. They're like less smooth. You can even like do this as like 1 and do this is like 2, and it'll be even more like hard edge. You can see how like hard edge it is now. Now it's like more like polygonal. So that's also like really interesting, I think. So yeah, I mean, it starts to look really cool really quickly. Once you get everything set up, then you can have like so much fun with it. But we'll show the blended method in a minute, because in this case, no matter what we do, the connection is always the same proportion. So if we want to mess with the connection, we got to do a different method. But this is really cool, actually. I didn't play with the hard edge version when I was setting this up, and I think it looks pretty cool too. What do you all think? How do we rotate this structure on a central axis? I guess yeah, just rotate these on center, if I understand correctly. The guides. Yeah, this Walter, it's very like, it can look very like spiny. All right, let's move on. Yeah, anything's possible. You just have to think about like how to make it. You can then do the morphing, and then you can find the naked edges at the top and the bottom, and then like decide to do something else with them, like extrude them and this and that, and you know. So this doesn't have to be the stopping point, even though it's like our stopping point is the tower. You can do things to it after like that. So. Yeah, I'm doing the mirroring now, I guess. Uh, it's pretty straightforward. So I just wanted to show that there's other ways to like smooth stuff as well. And if you want, I don't feel like trying it, but you can also do surface sub D for mesh. Like you can convert this back to a sub D. Maybe I'll try that afterwards, just in case it hangs. Sometimes it's quick, sometimes it's not. Really depends. But you could convert it back to a sub D. So just keep that in mind. Okay, now that we have that, let's look at how we can mirror it, like to create some cool like symmetrical geometry. So what you'll do is just make some space here. It's going to happen here in the zone. And we'll just get mirror cut mesh, mirror cut mesh, Pufferfish. Basically what it does is it takes a plane, cuts through a geometry, mirrors it, and like bridges and smooths across all with kind of one component, which is nice. So we're going to mirror that, and we need a mirror plane to cut with, and we can define that with a point and a rotational plane if we wanted. So I'm just going to I'm going to drop down a point that's going to represent the like position of that mirror. set one point. Just going to cut. I'm sorry. We're gonna start with a plane. Let's start with a YZ plane because we're like in the Y and Z direction. I think I just want to like mirror that way. So set a YZ plane. I'll increase my plane sizes so you can, if you go to display plane size. Okay, so you have a plane. That's going to be our cutting plane. But first, I want to be able to rotate that plane around, so we're not just stuck in one axis if we wanted. So we'll get another Pufferfish component called rotate Euler. Rotate Euler. I mean, the rotate components, they just make it easy to rotate multiple axes without having to use many components. And actually, we don't need a geometry. You could use a geometry and rotate a geometry, but in this case, we just need the plane. So the start plane, PL, it's going to be that plane. And axis, you can change them. We're going to keep them as 0, 1, 2, which is mean it's going to first rotate X, then it's going to rotate Y, then it's going to rotate Z. And then these are the degrees for each A. So it's going to be rotation degrees for X, for Y, and for Z. So we can get something that is like 360. Let's just make that. Let's make that max 360. And we also want to go like negative too, so we can go the opposite way. Negative 360. And I'm just going to set them all to 0 at first. So what that's going to do is, if I look at the final output plane here, what that's doing is it's going to let us rotate this. So I can rotate it like X, and then on the Y from there, see that as Y, and then that X is Z. So it just lets you easily rotate that multi-directionally. So let's just start at 0. And that will be our plane. So now you have this, right? And you see how it like, if I go to previous images, it like connects them properly. And if I move this point, which is here, so you can get these very like vessel looking kind of structures, and it will kind of connect between there. The other interesting thing is like there's two settings here. There's reach and offset. So reach. Offset. And then you have, just want to show you some options there. Boolean to flip. So like if you want to flip which direction the cut is happening, you can flip like that, right? Reach is going to say like how, you can see this plane going here. It's like how much is it going to cut away and then connect back to the original plane. So that's the reach. Actually, I'll turn this. I want to visualize these two planes here. The reach plane and the offset plane. So here's the reach. So you can see wherever it's going is where it's cutting, and then it's like connecting back to the original plane. Then there's offset, which will just like offset everything from that. And if you do like an offset or something, you have these other options. Like there's different connection types. There's different bulge factors. so you can determine like how those should go negative too. So you can go negative or positive. And then you also got divisions, like how many divisions in the connecting bridge. See there, so how many mesh divisions. So all fun stuff, but we don't need we don't need the bridges and stuff right now. So I'll just leave these at 0. Okay. And then we just put that mirror in here. And we look at our output. So if we look at our output here, and so there you go. So like now when you're messing with that mirror, if you change like the rotation, you can even like do stuff like that. You can move this point around. Maybe you want it to rotate into this direction. So a lot of really cool stuff really quickly once you have the system and the unit set up. Then it's just about playing. Which is cool. And so then where's that bit? I was grabbing the attractor. It's like hidden in there. There we go. That was just the attractor point I was touching on accident. So if you just like put the attractor up, see now you flip it again. So really can do you can play with this all day, honestly. I never know when to stop when I get into something like this. And the last part I want to do is just like separate it out for easier like baking. So you have that. What we need to do is shift the path. This might be confusing, but basically there's two, like you can see that there's like these extra ones. Basically what's happening here is this is the base because they're all connected. And then these ones that have 1 in the front, that's like all the details that are mirrored. So what shift path does is it takes everything that has like the same address 1111 and we'll put them in a list. So you'll see if I plug this in here, you see, so everything that was like 00 is the base, but then everything that was 01, everything that was 01, like all this went here to this list, and then the 000, because it has a different address, like the 00 versus 01, into its own, and so that's why there's like 28 and 1. As much explanation as I'm willing to give right now just requires some experience with data trees. So anyway, the reason we did that is so that we can have these separate. So we'll get a explode tree. And now you have this branch in one output and this in another output. And you can just get like a, let's say data or something. Make this a different color. This one. So now you can just visualize the details separate from the base. Cool. All right. Just as a forewarning for anyone that's here still, a lot of you are still here. Well, let's take another 5-minute break. Move on to the last definition, which is like the one that does this by blending, and then we'll show a little KeyShot, and we'll be good to go. So 5 minutes, and we'll definitely be going over today. So whatever, it's okay. More stuff for you, but if you can't stay, feel free to leave, watch the recording. See you in 5. Hello, everybody. I'm back. And you can just check the website to know if you'll get a recording. It's listed in a bunch of places. We'll arrange on a mirror work. Oh, not sure exactly what you want to do with arrange. I don't know. Depends. I don't know what you're trying to do. If you want to do like multiple mirror cuts, then you have to chain them together. Just put one after the other, or you can run them in a loop. I have an example of that on my example files using Anemone, which is a plugin that lets you do looping in Grasshopper. You can check that out as well. But no, it can't loop. It can't loop on its own. Okay, so we're good there. Let's do the version for for this one here, which has like the bigger openings. So I'm just going to. We can use actually the same inputs. We just turn this off. I'll just turn these ones off. I'm just gonna copy everything, and we're just gonna like dismantle this a bit and like that. And so that's what I was saying, like how you can put like, it's easy when you have this like connection, you can just connect things easier, I think. Okay, so with this one, the order, if you remember, has to be a bit differently. We have to, instead of tweening and morphing, we have to morph and then morph twice, like the units to each one itself, and then do the blending afterwards. So we're going to keep the same setup, base detail, but we're going to connect things a bit differently. So first thing we're going to do is we're going to not entwine. So we'll just get rid of that. We're not measuring to centers anymore, because at some point we're going to measure to the vertices. So we don't need that. We don't need the tweening because we're not tweening. And so we'll use this. Move it off to the side. So first thing we're going to do off the bat is we're going to get a merge. And we're just going to put them in order of base, detail, base. And you can just zoom in and delete that extra input it adds there. You don't need that. And then we're going to, let me just disconnect. Oh, no, that's fine. I just want to stop it here. Disconnect this. Here. All right. So we're going to plug those merges into here. We're just going to graft so that each thing goes in its separately. So I'll explain that in a second. And again, we want to use the naked edges. And let's not forget, before we get too ahead of ourselves, that we need to set in these units here, which is in that file I gave you units, and that's going to be A and C now. So for tween was A and B, we're going to do A and C. So details AA we can keep, but we want to change these. So we want to change these to C. See, and then get this one here, the bigger opening one, and change that. So set one, sub B. And then the detail of that one, detail C. Okay, so what's going on there? We do need to change these because it's still the same geometry, but we've moved it over here. So we do need to change them. So set one. There we go. So we have our thing in our bounding box and we morphed it. So now what's happening is each thing is in its own like we did before. So basically you took base A and put it in every box. You took detail A, put it in every box. You took base C and put it in every box. You took detail C and put it in every box. So if I just quickly join these, so I'll just go to join. And flatten. So now you'll see you'll have 4 meshes there. And you can even see like that they're like base detail. But if you just bake that, I was baking on the red layers for some reason. So now you have 4 things, and they're not blended. They're just the unit as they are. Right. So you put like base A, detail A, base C, detail C, just as they are. Just strictly morphed into there, no blending yet. So now what we need to do is we need to structure these things in a way so that we're blending bases to bases and details to details. So one way we can do that is we can just get a list item. And just click plus. So that's it's just gonna basically just separate each, it's a quick way to separate each thing into its own output. We'll get some merge, right? So we know that we went in here, base detail for the purposes of this morphing. But now we need to order it as base, detail. So we know it's like currently base, it's currently base, detail. So what we want to do is go base. So now you have your bases. Kind of hard to see, but and your that changed the base. Let's just say bases, details. And we're going to then entwine those so that it's 2 lists. So now if you look at it, you have one list of two bases and another list of two details. And that's what we're going to blend, right? So now when we blend, it's only going to say, okay, it's going to say, okay, blend the two bases and blend the two details, but don't have like we don't want those to interact. Like we don't want the bases to blend to the details or details to the bases. Probably won't work anyway because they don't have the same topology. So that's the reason why we did that. So we'll get our blend meshes, two meshes. Okay. And now we just need to measure to the different vertices like we did before. So now we're measuring to the vertices rather than the twisted box center. And we need the vertices of one of the bases and one of the details. Just like before, it doesn't matter which one, because both bases should have the same amount of vertices and both details should have the same amount of vertices. So we'll get a deconstruct mesh. And I'll just grab the first base and I'll grab the first detail, which is coming from +1. Can anyone else hear? Okay. Can anyone confirm? Yeah. I guess if you can't hear, then it's on your end. Okay. So thanks for confirming. So now you have those. We're going to do the same thing. They need to be in a list similar to this one. So we put each vertices in its own list. So we're entwined now. So you have here, you have 880, 1000, right? That's your base vertices and your detail vertices. And we're just going to measure to those with our attractor. So we'll just put that in there. Same kind of usual setup we use. And we're just going to plug those into our factors. Okay, so what's happening there is you have two bases. Each base has 880 vertices. And you're giving a factor, 880 factors, one factor for each vertex, one blend factor for each vertex, and the same thing for the details. That's how that list is set up. And then from there, it's just the same. It's the same setup as before, which is this business here, where you just then join the meshes and weld it and mirror it, and you end up here like this. But now the difference you can see is that you're getting like the thicker openings at the top versus like those thinner ones we made at the bottom. So if we look at that compared to these ones, you can kind of see they're like stringy there. Like, so if we focus on this pipe here, this like connection, and I hide these, you can see, right? Like, so that's like always the thin connection. So that's the way that you do, like, if you want to change connection thicknesses. Stuff. Okay, so there you go. That's basically that. So those are the two methods. Oh yeah, sure, I can save. So those are the two methods. Really fun stuff. I would say, for these ones, the process is there. Honestly, like the exact shape isn't as important as the process. It's the same exact process, just pulling different things around. So you have the file. So because I want to move on to like other stuff. So and this is kind of like just pulling things around. So just take a look at it, bridge things, pull things around, deform them. It's the same idea. And if you want to use any of these, just replace them here. A, B, B, A, C, C. I've put them all like, so if you want to use unit 2, they're like that. So like there's base A. There's base A. There's detail A. Base B. So base B. Base C. So it's just taking the different unit and replacing them in those inputs. And you'll be great. It'll be good. So definitely also like try those out and see what happens when you like use these different units. Like they're all the stuff you see on the website. So these are all made with those 3 units. So that was like the first. This is the unit we just made. This is that second unit. And this is that third unit. Definitely, try replacing those in and try making your own. So next thing that I want to just do real quick is I want to make a small like landscape. If you see for your renderings, which is quite nice. If you see here, there's like this kind of abstract thing in the background. It's nice to give your things like some kind of background. Like I like this kind of abstract stuff. It can be whatever you want, but I just thought it was cool for the renderings with KeyShot. So we'll make that real quick. And also remember, play with these too. So, because there's a lot of fun stuff. For another one I could think of that could be useful for this is like the twisted box sweep. If you wanted to control this a bit differently, you could use, instead of curves in this direction, you can use like rails in the other direction. So if I just go to like this, and I'm just gonna make these real quick. Like if I just did something like and again, you have all this stuff in all the ways to do this, like in example files too. So let me just this for something. I basically just drew curves in this direction. So if I like hid these, let's say I hide these, and rebuild these, just to give more points. And I could set those, like there's different rails, so you can just do a curve, set different rails in. So set one curve. And it's 4 because twisted, boxes have like the 4 edges. And then just plug those in to each row. Right. So that's like another way that you can control TUSA boxes that I can see being useful for this situation, let's say. And then you just replace those. Just replace those here. Like, so if you wanted to use that instead, you can just. Just put that there. There you go. So you can mix it. You can change the system of twisted box as well. Really up to you. So definitely check out like all the things you can do with twisted boxes in the example files. All the different ways you can make them, manipulate them. Yeah, files are updated. Okay. Let's make a quick landscape and then move into KeyShot. Before we get there, find something that you like. I'm just gonna choose this one right now, real quick, and bake it. If you go to result, I like to be organized, so if you go to V1, bake, you can bake the base. You can put the detail on the detail layer. And then I'm just gonna turn all this stuff off. Again, if you open this file, just something to know when things are great like this, there's off. It's just so when you open the file, it just doesn't like process a bunch of stuff like crazy and slow you down. So if you want to use something like, say I wanted to do this, just turn it back on, enable it, enable everything, and there you go, it's back on. But it's good practice to like disable stuff when you close a file, especially if you're going to give it to other people, because I could send it to someone with like a not so great computer and then it's hanging because it's like processing, and so good to keep things off. Actually, what I like to do is once I know that's the one I want to bake, I'll pump up the smoothing to 3 here. So just put that at 3, just so it gets much smoother. And then I'll bake it. And then now we have that. I'll save, and let's make a quick landscape, and then I'm just going to move this off somewhere. Somewhere there. So first thing we're going to do for like a landscapey thing is we're going to make a plane, like just this determines like the size of the landscape. Just gonna check if that's below. So let's just get a curve component. I'll just do this like over here. So it's kind of like extra bonus. And I'm just gonna make a big, in this landscape guides, I'm just gonna make a big, just like a big. Even bigger. And I'll just move this for a second while we're making this. So you have like this big rectangle, and we'll just set that in here. And we can use a Pufferfish, which is called parameter divide rectangle. So parameter rectangle grid. So it's like a rect grid, but it lets you use parameters. It's too many. It's 100. And so we're not gonna do it here, but you could like, if you did the graph, you could change the proportions of stuff. Like you can see how you can make it like bigger and denser there. But we'll just keep it like that. So we have the rectangle grid. We're going to get the centers of each cell. So polygon centers. Flatten the outputs. We only need a flat list anyway. So now you have the center point of each thing. Throw down an attractor. I'm going to toss it like somewhere right in the middle. Get a point. Set one point. And we'll do our favorite, our favorite routine that we always do with these, which is like kind of this here. The usual kind of attractor setup. But this time to the centers, I'll use CA, which is area center, and then now what's really cool is that with graphs, you can like mix them through multiplication. So we'll get like something like that. And we can take this one and make it like a sine wave. You can make some like crazy sine wave. That's this a bit. And then just multiply them. Because they're all under 1, like they won't exceed 1 when you multiply them, which is good. And the next thing is I want to add a bit of like jitter, but I'll first I'll just show you what it does without the jitter. So we want to extrude, right? So we want to remap the numbers. We want to remap these values to like a minimum and maximum value. So we're going to construct a domain. Go to 1,000, but we'll decimals. And we'll just go to 300. Basically what this is going to do is like based on our attractor, the smallest height will be 1 and the biggest will be 300 in this case if we keep it at 300. And then what we'll do is another Pufferfish component, which is called parameter. I can spell it correctly. Parameter extrude mesh. Okay. Has a lot of options. We don't need them all. And we're just basically going to extrude these curves by the Z direction, but we don't want to plug in the Z direction yet. First, what we want to do is there's this setting here, which is called L, which is lengths. And what that will do is it will divide the mesh exactly to each length between the polyline control points. So basically, it's going to, if you have a rectangle, it's going to make the mesh have faces that are exactly the edge rather than faces that are like this, like that would be like divided across. So we just set that to true. And then the other thing is like how many divisions do we want in the height of the mesh extrusion? And we only want one, so we do our like little trick from before. Just type 1. We don't need to put parameters in there. We just want 1. We get Z. And we're going to be going basically by these distances in the Z direction. So you see you have something like that. Okay, so you have something like that. So you've mixed these two. Like, so if I put like just the sine wave, it's going to be like super high and consistent. And if I put just the fall off, it's just going to be like a regular. It's going to be like a regular fall off, right? So by multiplying it, you just mix the two graphs, and there you go. Beautiful. So that's how you mix like graphs and stuff, which is really cool. But the other thing I want to do is I want to add like a bit of variation here. So we can use jitter, but you just have to be careful with jitter. It's very sensitive. So jitter, what it does is like mixes up the values a bit. So you can just do like 0.0001. Like anything more than that is going to be too much. And it goes to a maximum of 1. So we'll just do that and then plug that in there. So this is just going to give it like a tiny bit of randomness, but still keep like the overall pattern. Lastly, I do one step of constant quads. So it's default to 1, so I just do it by 1. If you do too many things, it might be kind of heavy depending on the computer you have. And then we'll do a 1 catmull arc. And then we can just preview. So you get something like, oh, we forgot to cap it, right? So there's also a cap here. So just like cap it as well. Just put in C, just put true, so that it closes the tops off. But there you go. So that's kind of how I made that. And then you can play with the values. I suggest like playing with it. Like what I do is, because this part can be kind of heavy, like I'll do something like this, and then just like turn this off until like I have something. So I have a like more fall off or something. Nice. And then once you're happy with it, turn this back on just to get the final thing. If it's too slow for your computer, just use like different less divisions here. Use less cells. And then so in results, I'll just put that as the results, V1 results, and just date that Cap1 Clark. Is it possible to have multiple senders? Yeah, just add another, just add multiple points. That's all you gotta do. Just put multiple points and you'll have multiple centers. Let me turn that off. And so that's it for the Grasshopper parts. Once you have your two things, let me just save this. Let's minimize. Then you can take your tower, and it doesn't have to be this. I mean, you can use anything. Put it in any scene. Just like something looks better than nothing, you know. And you can put that in there. So then we can, you know, go and render this thing and, you know, make these cool like abstract renderings. Just want to move it up slightly because I can see that it's kind of. Maybe I kind of want to. I feel like I kind of want to. Anyway, do your own geometry and whatnot. It'd be cool. So I'm going to save this. So if we just took a look at this in Arctic before going to KeyShot, I mean, it's pretty cool already. I think that's pretty nice, and it's very like NFT aesthetic. You know, this kind of stuff going around these days. So that's nice. Okay, so next thing is so next we'll open up KeyShot. Okay, so when you open up KeyShot, if it's the first time you've ever used it, it might look like that. I think that's how it looks when you first open it. Just kind of like nothing there. Firstly, you can go to edit preferences, and you can turn the theme to dark. If you, I like the dark mode more, so I always use the dark mode. And then just go to like window, library, and select like materials. So window, library, materials. It'll bring up this whole like side panels that has like a bunch of stuff. And then also Windows project scene. And that will bring up the scene bar. So you'll have these two bars on the side. That's usually like, I don't know why they don't have it up by default anymore. It used to be, but I think when you just download it now, it doesn't show. Two things. Depending on the type of computer you have, in my case, I have RTX 3090 GPU, so I can go into GPU mode. If you don't have a higher GTX or an RTX, I would suggest not doing it. It might not even work, or it just might crash. So I'm going to go into GPU. So you just click that button, it goes into GPU mode, which just makes it insanely faster if you have the right graphics card. And then also denoise. So denoise, basically is using denoisers, if you're familiar with them, like optics. They're using like AI to kind of falsely remove noise from an image, and it's actually really quick and like so much better than waiting for rendering to clear up. It's just like AI kind of like looking at the pixels around it and understanding like how to make it look unnoisy. So I always have those on. But if you don't have a good GPU or the right kind of GPU, just turn it off. But you can have denoise on. It's fine. Now in the folder, in the Dropbox folder, there was a KeyShot thing. So KeyShot, and there's environments and materials. They're just the environments and materials I used for those promo materials. If you want them, I can just show you. So basically, you should go to wherever your KeyShot like files installed. It's usually in my documents. It usually goes. So if you look at my documents here, you'll see that there's KeyShot, and then there's a folder in there called downloads, and that's where you want to put these. So if you go to KeyShot 10 downloads, it's usually in my documents. If you go to materials, you can just take these 3 materials and copy them in there. And if you go to environments, you can just take these 2 HDRs and copy them in there. And then that will put them in KeyShot in your like downloads tab here, right? And these are other ones that downloaded too. And if you want other materials, so if you want other materials, you can also use any of the materials. I mean, there's so many materials that come with KeyShot, but if there's other ones you want to try out, you can just go to Window Cloud Library. And so basically, the cloud library is like an online library of clouds, of materials, environments, backplates, textures, models from KeyShot users, and some from KeyShot itself. So people just upload their materials they made or whatever, and you can just like literally drag and drop them from the cloud library into your downloads, and then you'll have, that's how I got all of these ones. So that's nice too. So in Rhino, so now that once you have those in their setup, in Rhino, we're just going to export these. So I'm just going to select a base, select objects, file, export. And I can put these, I just put them on the desktop for now. I'm going to do OBJs. And I'm just going to name this one base. Save. And you don't have to do it. It's already a mesh anyway, so it's okay. And you want to go to formatting and make sure you have like map Rhino Z to OBJ Y, because most other softwares that use OBJ use Y up. So make sure you do that. And that's the only setting you should have to set. Map Rhino Z to OBJ Y. It's probably set already by default anyway. Okay. And that's exported, and then do the same for the detail. Select objects, file, export. Then this one, objects, landscape file, export selected, and then just name that landscape. That one usually takes a little bit longer than the others. It's quite a big mesh, so just let it export real quick. Okay, it's done. Depends again on your computer, like how fast that will happen. And I'm actually going to put those. I mean, I could go faster, but it's all right. I mean, if you don't mind it, get that folder up again. If you don't see anything on my screen, it's correct. I don't have anything on my screen right now. I'm just like trying to put these in the folder. Let's see where it's at. I'll make a new folder in the downloads for you. Let's see. Well, if you want landscape, it's half a gigabyte, but I'll put it there anyway. Just don't download it if you don't want it. It might even take a minute to upload there, but it'll go eventually. So if you want to use those, you can use those. It's fine. Oh, it went there pretty quickly. Anyway. Okay, so now what I'm going to do is, so you have your base detail landscape, and with KeyShot you can just drag and drop stuff in. So we can get the landscape in there. We want up direction Y because we mapped Z to Y, and we want to keep position relative to native origin so that it stays in the position we exported it in. It might be default if you go to position. It might be default to center and snap to ground. You don't want that because then it's going to center and snap the details and bases in a different location from each other because they're not like the same size. So just keep position relative to native origin. Up orientation Y should be the only thing you have to set, and import, and then just let it import. That's there, great. And then we'll import the base. And we'll import the detail. Cool. So you can see how nice, like the with the denoiser, like how quickly it clears up. I mean, it's a lot quicker than without. Then also I'm in like GPU mode with 3090, so it's like clears up like pretty quickly. It's like almost instantly. But it might not be that fast for you. It really depends on your computer, especially if you're using a laptop or something. Maybe you can or can't hear my graphics card going crazy right now. But anyway, once you have those in, the first thing I like to do is, I think that the few things that make like a nice image in KeyShot is, firstly is the environment, right? HDRIs make everything look so much better. This is the one I used for the promo material, which gives you like this kind of nice sky. You can rotate the model so that it looks better, or just rotate the sky. There's also this one, which is kind of nice, which is like a more like green blue scheme. You can roll with that for now. Then just kind of find an angle you like. If you want to change the lighting, you can go over here to environment. You can actually edit this HDRI too. Like if you go environment, HDRI editor, you can change like the hue and stuff of it. So if you wanted it more different kind of color scheme. And you can find HDRIs like all over the web too. There's just so many different kinds of them, but I'll just leave it at what it is right now. So you got the environment, but also if you go back to settings here, you can rotate you can see in the back like it's rotating. So you can rotate the lighting to get like a nicer lighting that you like. Like just rotate it until you find like that kind of whatever lighting you're looking for. And also, if you don't want to see the background, you can just go background and change it to a solid color too. It'll still keep the HDRI settings, but we'll get rid of like the actual image. And you can even put a backplate image, which will pop this up, and you can put any image in the background. You can do something like crazy. Like that, or whatever you decide. So then it's important to like find a good angle. And for the angle, you can, mess with things. By the way, zoom in and out is with the wheel pan is holding down the middle mouse button. And orbit is left click, left mouse button. Okay, so and then also there's the perspective angle, which can really add some like drama. Or you can have it like more axon looking. So you can have more, make it more dramatic when you like zoom in closer to it. So you have something like that. I kind of like seeing that in the background of it. So now it's the materials. So the materials I used are the ones I gave you. So if we just go here to our on the left here to materials and downloads, the materials I used was I was using I think it was called like Mayo and Magic More. Yeah, Mayo. I was using for like this. And then like for the shinier, I was using for like Magic Morning, maybe for the details. So you can get something like that. But you can also use other stuff too. And then I think for what was the other one I used? It was like porcelain or something. That's what I used for like the background. Don't seem to have it. Oh wait, I think it's called cracked porcelain. Yeah, there it is. So that's what I used like for the for those, but then I just like change some colors. And also, if you use a different black environment, like if I use this one here, it's gonna look different. See, so you do that, and then you can, if you go to the material on the right side, for instance, I can go to that cracked porcelain, and I can just change its color. And I was using like a blue. I don't remember exactly the settings I was using. Something abstract. And maybe you want like the setting. Change that. Maybe we want it more reflective. And then we can go to this, like maybe we want to change so I can change the color of this one to I think it's just going to pick up like the HDRI in that case. So now materials, and you can try other materials from downloads or just from like in general stuff here. Something. Let's see. Liquid. I like to be abstract with it. Metal. That's kind of cool too. Anyway, I'll leave it to you. Some bubbles. I want to make this shinier. Anyway, you just gotta play with it. It's just like with the model, just same as this, just like play and test and check it out to get something you like. Anyway, so once you have that, like once you have something that you like and you found a nice position, the next step is to do go to camera. We're going to put the depth of field. So just click depth of field and it'll get like probably pretty blurry at first. But you have this little target here and you just click it and then you select on the model like where you want the focus to be. So like I'll say I want to focus like in the middle there somewhere. And then you hit done. And then you play with the focal stock, which is like how strong the effect past the object is going to be, or in the front of them. So I want to clear the object a bit. So I want to give it a little bit more, right? So it gets past the object a bit and like blurs more like with the background. And then you can also play with other things too, like in the image, like different lighting type. Like you can try with product design. There's different presets for different kinds of design. And you can also do custom too. I'll just keep it on basic for now. So let's just say like, let's just say we like something like that. You also can then change the image and just click that link and you can just pick the size you want it to be. Like I was doing for Instagram like 12, because Instagram is squares, so I was doing like 1280 by 1280. Like that. Zoom in. Set this. When you move the model around, you should refocus the focal, the depth of field. And so then that's that, right? So then when you're ready, you just go to render, and you go render. And then options, depends what mode you're using. I usually just leave it to inherit from real-time view. So if I'm in a GPU, actually it seems out. For some reason I was out of GPU mode. Go to render. Buy the full version. You can't really get past the KeyShot thing. I mean, they do that on purpose, right? So no other way around it if you want if you want to not have the watermark. Um, so options, inherit from real-time view, in my case, GPU. If it was CPU, then it would look like this, and you can select all your cores or use the real-time settings from the scene, but I'm going to stick to GPU. There are some, and maybe it'll happen now, I don't know. There are some materials that are not GPU compatible, and it will just like crash to render. I think when I'm using this GPU compatible, but I guess we'll find out. And then I usually put the samples up to like, I don't know, like 2 something, like 250. But this will make things take longer. So really depends. The more samples, the better your rendering will be, but the longer it will take, essentially. And then you want to set this to be, I mean, you can render any size you want, but I'll just do it like to the same size as my scene. And 300s is a bit much for things like, if you're rendering for, I'm thinking about Instagram, like rendering for Instagram, 300 is not going to matter. It's going to downsize it anyway. 300 is like if you're going to print it for a magazine or something, you know. So you really want to go, you can go from like 70 to 150 is good enough for web. And then, yeah, and then you just hit render, and it should be like, this will pop up, the renderer, and it'll be rendering. You can see it's because I'm in GPU really fast. It's like, oh, I mean, it's done already. So that's done. And then that will go to that same KeyShot folder, wherever your KeyShot was installed. In my case, documents, KeyShot 10, renderings, and there it is. All nice and pretty and good to go. So that is, I mean, that's basically it. Why don't we just take a last 5-minute break and come back and do some like Q&A. So in that time, maybe think about some questions, and I'll come back and we'll answer some questions. So see you in 5. Okay, I'm back. Let's see. Okay, that was a lot of information in a short amount of time. Thank you for sticking through. Question I want to be able to recreate that style in Rhino. Yeah, Bionic Artificials is completely based on ZBrush because you can't do a lot of that stuff in Grasshopper. I mean, you have different softwares for different purposes. If you're interested, I highly suggest to do it. I'm sure you can get like ZBrush must have a trial version. It's one of the softwares I use every day as well. Every day I'm using Rhino, Grasshopper, ZBrush, Maya, and Houdini. I mean, those software all have their own uses and purposes, so I'm using all those there. Any other questions, or does anyone feel like they want to ask a question on video? They can raise their hand. I can bring you in the camera. Any questions? Yes, I know. How can I apply to work at Nike? Yeah, just go on their website. All the jobs are listed on their website. If there's an opening, that's what you can apply for. I also want to, how do I like my work at Nike? I love my job at Nike. It's the best job I ever had. It's a really, really great job. Really a lot of fun. Let's see. I also want to thank Ayo for being my safety here in case I lost internet.
Thank you, Mike, for this amazing. It's always amazing to learn from you. Thank you so much.
Go check out his Instagram. He's always doing such crazy renderings and work from the webinars. Right, in this way, without limitations. I don't know. Everyone's different. You just gotta practice. I mean, it looks easy when people like me do it, but you have to remember I've been doing this almost every day since 2011. So at some point you just get good at it and it's just not so difficult. For me, like the challenging thing is Houdini now because it's so much different in its structure than Grasshopper, but I keep thinking like Grasshopper, so I have to try to forget Grasshopper, which is really hard because like Grasshopper is like, you know, doing it in my sleep. It's just like everyday kind of stuff, you know. It's also what I'm doing every day at Nike, so. How much freedom? As much as I want. Yeah, I mean, as long as it makes sense and works. It's all about the creativity. Differences between Houdini and Grasshopper? Yes, just because they're both nodes, they're nothing alike. They're just completely different things. You know, Houdini is just for simulations and like all this stuff. It's just, yeah, it's just completely different. It doesn't work with data structures. It works with like assigning attributes to things, and it's like completely different idea or way of working than Grasshopper. So if no one wants to come live or ask any other questions, maybe we should all be finished with this and take a nice rest of the break, rest of your day or night off. There's nothing else to do besides practice. I mean, really, like the best way to learn is honestly, like for me back in the day, was just going on the Rhino forums and just trying to solve other people's problems. You learn a lot if you just try to solve problems rather than like always watching tutorials. Because if you find a problem and you try to solve it, you're forced to like be resourceful. I do a lot of Googling, of course. But yeah, it's the best way. You don't have to post the answer, just like find some problems and struggle through them without like a tutorial helping you. And you'll find how to research, how to mess up stuff. You know, that's the best way. Just find some problems and then just do it. Like just try to struggle through it and solve solve it. That's the best way. There's no better way than that. And that plus like intro tutorials and then like some webinars like this, like some workflow one, but I wouldn't rely solely on that because then you'll only know how to do with those webinars. You won't learn how to like think in a way of solving problems. I think that's the most important thing, is just to change how you think about solving problems. I'll ask Gilligan, Gillan, or that's how you pronounce it. We've already done webinars on machine learning and AI. 3 of them, I think, already so far. So sure, there'll be more. Houdini isn't superior to Grasshopper. It's just different. I use both for different things. They're just different for different purposes. I mean, like it just really depends what you're trying to do. But there's no reason to compare them. They're just different software. It's like saying a ZBrush better than Grasshopper. It's just different for different stuff. So don't try to think about what's better than what. It's just like you just have to know what the tool is good at and just use it. It doesn't really matter as long as you get done what you're trying to do. Some books on swarm intelligence. Sorry, I honestly don't like. I don't own. I mean, I own some books, but they're just like buried away somewhere. I don't really look at books so much because I just look. Whenever I need to do something, I just look it up online. I don't find much of what I'm trying to do there. But if you just like Google swarm intelligence, I'm sure you can find a lot more useful information than like the book. But just like the internet is so available now and updated. Once a book is made, it's kind of like made and it doesn't. It's outdated at some point. I would suggest searching online, honestly, but that's just my opinion. In this realm of work, it's all there already online. And Google is so much better than trying to look for a book. Right? Just Google swarm intelligence, and there you go. You'll have years of information to look at. Your teammates, anyone want to choose other softwares and free webinar are quite efficient for learning how to work in softwares. I don't know. We're not focused on free webinars. We do that every once in a while, but so I can't say that that's our focus to try to do a free webinar for every software. You have the resources, intros, and then the other webinars, which are quite accessible. Do you think designs can be used outside of Planet? Sure, why not? What is your typical workflow for modeling in general? Well, kind of like you just saw, it's a mix of like manual stuff, parametric stuff, computational stuff, coding. It really just depends. Like there's not one way. I really like. I have a problem and I just do what I need to do to resolve that problem, whether it's manually doing something, whether it's computationally doing something. Just there's no like correct answer for that. Describe your workflow from design to production. Yeah. For what? Like what exactly? If you're talking about Nike, I can't really answer that. Contracts and all. But I would imagine it's similar to any other design to production process. Do you ever physically make them all the time? Yeah, we made one with Arturo Tedeschi recently, a lamp that was really cool. You can see it on our website in designs. It's the first one there. Like that. Why is the course not able? We had a webinar on neuro connection. Yeah, so we don't. Design Morphine isn't a subscription service, so we don't. We do webinars. They're exclusive, and if you're there, you're there. If you're not, you're not. And then there's other ones, and this also makes the program have to keep staying fresh because we do V2s and 3s and 4s, and so things always have to be updated. We're not trying to be like another subscription model. We're like very in the moment and up to date. So that's kind of how we're going along with things. No, we probably won't make any past webinars available again, but we will do new ones. So that's always the good thing. Always keep updating. Will the recording of this webinar be on your site? No, it will not be on our site. It will be sent to you. How often do you move between different softwares when modeling, excluding rendering softwares of KeyShot? I don't know, like all the time. That's what I'm doing, if I have to do some crazy mesh stuff, I'll probably be in ZBrush. If I had to do some UV stuff, probably in Maya. Maya's really good with UVs, Grasshopper stuff in Grasshopper. Just depends what I'm doing at the moment. Will we get a certificate for this webinar? Check out our websites. The answer will be there for you. The answer is yes, by the way. My roadmap career was work in construction, and then architecture school, and then working in architecture offices, and then working at Nike. At the same time, doing design morphine, teaching, and learning how to code. That's basically, if I had to sum it up shortly. I don't work with Unity. I haven't done anything with Unity or Unreal. It's just like, yeah. I mean, there's just a point where like you don't need to know everything, And then in the work I do, Unity and Unreal aren't kind of important for the work I'm doing. Because I'm not doing any kind of like environments or VRs or like walkthroughs or scenes, I'm strictly working in like design, which requires like modeling, more heavy modeling tools. I think they're awesome software. They're just not, what I'm doing. Well, thank you for your nice compliments. There's so many new softwares coming, and each one does a different job than the other. I'm just wondering how many do we learn? Because the list is getting exhaustive to keep up to date with fresh work. So the software that I would learn, or at least get into, is first of all, think about what do you want to do? Like, you don't want to just learn software for the sake of learning software. Like, there should be a point, right? So in my case, the work I do, which is now, before it was architecture, right? So I was doing Revit. I'm so happy I don't have to ever use Revit again. AutoCAD, so happy I don't have to use AutoCAD again. But again, because that was like where I was thinking I was going. But in product design, so now I'm in product design. And the role I'm in product design, I'm not going to start learning, for instance, Unreal, because it doesn't have points for like my career or goal objectives. So you want to make sure like that, and you also want to make sure like where do you actually want to end up. For instance, like just take an example like Blender, which is like an amazing piece of software. But if your goal is to end up at like an animation house, then you probably don't want to learn Blender. You probably want to invest your time learning Maya because they don't use Blender. So that's another thing to consider is like what software is being used in your, like where you're trying to go, what you're trying to do, right? So I would say don't waste your time trying to learn every software in the world. Just waste your time learning the software that's going to help you get where you want to go. You don't need to know everything. You just need to know the software that you need for your personal kind of objective. What are parametric firms looking for when they hire us? Of course, that Zaha Hadid, the big. Well, I mean, I don't know. I've never worked at either of them. But it's more than portfolio. Zaha very much hires from their schools, which are BAA, DRL, and also they also hire a lot by who you know. So that's another thing, another important part of being part of the community. I think you're very unlikely to get a position there just with a good portfolio, because everyone's got good portfolios and a lot of people can do that kind of like curvy, cool stuff. But I think it's more also about like your personality. People want to work with people they can be around, and so of course, someone that's kind of friends with these people or in there or in their social networks is going to have a better opportunity. That's just the way it is in most places, most industries, most fields. So they're looking for these kind of skills, yes, but there's also another layer, which is that like kind of who you know. And it's nice, like, and schools are the biggest part of that. I mean, it's even like with our design Morphy master's degree, like we have a lot of our tutors are from like Zaha, Big, and this and that. So it's like knowing those people, they know you, they have a better chance of going there. Except AAD, yeah. Yeah, I actually never read it because I already knew Grasshopper by the time it came out, but I do have 2 copies of it just because my name is in it from Arturo. Any advice for students applying for master's of architecture programs in the US? Have a large bank account. Kidding, but really though, it's expensive. Advice, yeah, I mean, I don't know. It can be tough. I think what they're looking for exactly, I don't know. I wish I knew more, but I just don't know. I just know, like, especially in the U.S., it's expensive. Like, the U.S. is the most expensive. I think it's one of the most expensive places for schools. So keep that in mind if you don't get like scholarships and all that, or whatever they provide maybe to foreign students. Favorite project, architectural. I think my favorite project is probably the from Trahan, which I worked at, but I worked at after they did the project, the Louisiana Sports Hall of Fame, because it's very curvy and cool and computational, but also very well made, which you don't find often in a lot of these projects. Like, a lot of these, curvy projects and they end up looking pretty bad because they're so expensive. The materials are not great. But the Hall of Fame is just really, really spectacular. If you haven't seen it before, highly suggest checking it out. Do you know it? Do you guys know it, the project? Or? No one? Does anyone know? Louisiana Sports Hall of Fame. Yeah, sure, I'll share that. Here. Next, what do you think will be the next big trend in architecture? So this is a reason. Next big trend. I personally. That's not a question there, but anyway. Oh, there it is. Next big trend in architecture. I think I don't know. I think architecture is moving away from like the crazy, like crazy over the top crazy stuff. I mean, even if you look at Zaha's work, it's like getting more and more refined and simple, which is actually more like beautiful, I think, and less like crazy. And like if you especially like look at big, like how they've changed so much. I think going away from that, I think architecture is becoming more like optimized, and that's personally like another reason why I was personally interested in weaving is because I'm interested in like the formal stuff, which is really much alive in product design, and kind of dead or hard to do in architecture when it comes down to financials and clients and what people actually want to live in. So I think like optimization, there's so many optimizations. Like I see a lot of offices. I think it started with like WeWork and like even Zaha Big are looking into these kind of things, like you kind of like optimizing workspaces and how people move through buildings and like these kind of simulations and prefab kind of setups and I think these are the kind of things that are happening. Let me get that. Here's the link. Oh, someone said. All right, so I think we'll go now. Before we go, just want to thank you all for coming. I had a lot of fun doing it. It's always fun doing these things. I know it's late for some of you. I just want to remind you to take a look at the next coming webinars because I think that they will be worth going to. They're going to be really cool, and look at the CDMix conference as well. Yeah, so with that, if no one has anything else crazy important, we'll get out of here. Let's close this thing, and in the next few days, you'll get recording and certificates and all that stuff. Check your emails. Okay, thank you all.